My name is Robert Finlayson.
Welcome.
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 Welcome to Azure Cosmos DB Conf 2024.
Welcome to Azure Cosmos DB Conf 2024.
We are so glad you are here for the Azure Cosmos DB Conference 2024.
Azure Cosmos DB Conf is more than just a conference. It is a celebration of innovation and collaboration by the Azure Cosmos DB community.
We're so glad you're here.
We appreciate our community.
Thanks for being part of Azure Cosmos DB Conf 2024.
Hello everyone, welcome to Azure Cosmos DB Conf 2024. My name is Tara.
And I'm Stephanie.
And we're super excited to be your hosts this year. To view the agenda for today and our on-demand talks, visit aka.ms/Azure Cosmos DB Conf. All of our talks will be available after the show on YouTube, as well as some on-demand exclusive content. Throughout the show, we'd also love to hear from our audience through social media channels like Twitter or LinkedIn. So let's start with sharing where we're tuning in from today or what you're looking forward to most with hashtag Azure Cosmos DB Conf. We may even feature your message on the show.
Yeah, thanks, Tara. And if you find yourself asking, where can I learn more or where can I enroll in a feature, we do have folks in our YouTube chat where they're readily available to answer any questions. Our last housekeeping rule, we do want to make this space a safe space for everyone, so make sure to read through our code of conduct, which can be found in the link below. So Tara, we're super excited to get started. Let's get ready for our keynote with Azure Cosmos DB Vice President Kirill Gavriluk, along with some special guests from TomTom and MasterCard.
Hello, and welcome to our annual Azure Cosmos DB Developer Conference. I'm Kirill Gavriluk, I lead the Azure Cosmos DB team, and I'm so excited to have you all here today. Now, Azure Cosmos DB is all about apps, intelligent apps, and these intelligent apps has few things in common. To build an intelligent app, you have to iterate a lot, make a lot of changes. And to make those changes, you have to have your database be very flexible towards changes, with not enforcing any schema. Also, you want to use AI, and AI is best at reasoning over semi-structured and unstructured data. We don't need AI to reason over a table of floats. Databases are already great at it. But to reason over language, natural language, semi-structured data, that's perfect fit for AI. Now, intelligent apps learn everything they can about the user. And to do that, they have to handle uneven, variable, very high volume of traffic. The database have to provide high scalability and elasticity. At the same time, you want to provide contextual, real-time experiences to your users. And so, database have to provide real-time, low-latency responses to your queries at any scale. Finally, your app wants to be global. Most apps do, because users are everywhere. You have potential to gain users in any part of the world, and you want to bring the data wherever your users are. The database have to scale globally. And even if your app is not global, you still want your database to have redundancy to support multiple region deployments. Because if your app is down, your business is down. So you never want this to happen. Now, Azure Cosmos DB was built with these requirements in mind. It's AI ready out of the box. It has built-in vector indexing capabilities, and it's also built for semi-structured data. It is built for this fast iteration where you change your data shape, where a single collection, single database can handle queries from your V1 of your application as well as V1000 of your application. Azure Cosmos DB provides guarantees for performance and scale. It has flexibility and efficiency both for the semi-structured data it is built for, as well as cost efficiencies where it instantly scales to what your application needs at any time, while providing the same low latency performance SLAs. Now finally, Cosmos DB is known as the best database for mission critical applications. It offers you 5.9 SLA guarantees and performance guarantees with active deployments. Now, what does it make Cosmos DB best for AI? Now, first, it has built-in vector indexing and hybrid search. Today for MongoDB API and in the future for all APIs very soon. It has first-class support for semi-structured data, documents data, very flexible data model, and where you can store both vectors and your data in the same place consistently without requiring you to provision yet another vector search service. It has turnkey integration with Azure AI platform, including Azure OpenAI, and it has limitless scale while guaranteeing low latency, single-digit millisecond latency at any scale and 5 nines reliability. Now, AI is used for any use cases these days. These are just some examples of the use cases where a combination of Azure Cosmos DB and AI is the best fit. You have connected smart products that we're going to talk about later in the show. You have transaction processing at any scale, intelligent. You have real-time fraud detection, fraud prevention that we'll also discuss shortly. You have many customers, tens of thousands of customers have built enterprise copilots today with Cosmos DB. You have information, product discovery, catalog, retail, personalization and recommendation. All these scenarios, you can extract more value with AI, and you want to use a database that provides you flexibility, some support for semi-structured data, and scale. Now, let's go take a look at several patterns used in these applications. The first one you'll recognize right away, it's RAG, Retrieval Augmented Generation. This is something we learned how to pronounce over the past year. And for those of you who were able to avoid that, let me remind you how RAG works. You have the data, you store the data in your database, Cosmos DB in this case, and you vectorize this data, and you store the vectors so that later on, when the user asks a question to the app, we can vectorize the prompt and get all the most relevant data from the database and pass this data as a context to the large language model together with the prompt so that LLM can provide you the best possible answer, the most relevant answer. Now, with Cosmos DB, there are several advantages. When you store the data and vectorize it, you can store vectors together with your data in the same place, in the same database, because Cosmos DB provides built-in vector indexing capability. Also, in RAG, it's very rare that you just use vector indexing. You want to use a hybrid search, hybrid queries that involve vectors, vector queries, nearest search, as well as attribute filtering, as well as full text search. And those are the capabilities Cosmos DB gives you out of the box. Now, once you have the question, the prompt, and you retrieve the most relevant context, and you get the right answer, you may also want to store your prompts. Most copilots do. They store the prompts as a conversation history for two reasons. One, it's a semantic cache. So you don't have to regenerate regenerate the vector for similar questions that you already asked in the past. And second, so that you can extract the context of your conversation and provide this context, just like you have context for the data, you can provide context of the conversation to the LLM to get an even better contextual answer to the user's question. Now, vectors have broad applicability, even if LLM is not used directly. For example, here we have ASOS website. ASOS is online major retailer selling clothes. To show the users personalized real-time recommendations, you may also like products. Given a choice, ASOS uses vectors to capture similarity between the products, as well as behavioral similarity based on the prior purchase history of the user. Vectors really brings us a more powerful like clause in the query. It brings semantics to the database query. Now, finally, as AI use cases evolve, you will have more than one LLM involved in a given use case. These multi-agent use cases where multiple LLMs are conversing, whether it's hierarchical conversation or peer-to-peer conversation, requires a database that can capture fast, distributed transactional log, a database that can provide you a semantic cache of prompts, a database that can provide you conversational history at any scale and with low latency between these agents. Cosmos DB is a very good fit for multi-agent use cases as a flexible, schemaless database with a guaranteed performance SLA and limitless scale. Now, let me invite to the studio one of our customers, TomTom, are on the edge of using AI in their applications. I would like to welcome Massimiliano Ungaretti to our studio. Massimiliano, would you like to introduce yourself?
Yeah, sure. My short name is Massi, and I'm a staff data scientist at TomTom, where I work on data and machine learning for different product areas, including, for instance, the search engine that actually runs in many cars. But the past year and a bit have been all about generative AI for me. So we've been identifying different opportunities to apply different techniques coming out. And I'm particularly proud of the work we've done on the latest advances for voice assistants for use in cars.
That's awesome. It's really great to have you. Massimiliano, you guys were on the edge of, and you adapted AI very early. Could you tell us a little more about the use case where you use AI and Cosmos DB together for your application?
Yeah, absolutely. So that is the in-vehicle assistant I was talking about. This assistant lives in the cloud in the first instance, and we obviously needed some kind of database solution to get started. And so Azure Cosmos DB was kind of the go-to solution. To make it much more concrete, we've been, using the Python SDK because that was our prototype Python to interact with the NoSQL database. And primarily, the very foundation of any kind of assistant or chatbot is the conversation history, because otherwise we'd be like a goldfish. So that's the first place that it hit. But we've started storing other things in there as we went along. So in that way, it kind of also supported the prototyping process.
That's awesome. And what's the capability? You had a choice of many databases. What capabilities of Cosmos DB you found particularly useful for your scenario?
Yeah, so I learned from previous projects that, taking off-the-shelf managed services is a great starting point, usually. And so we started exploring them. But basically, most of the candidates that we ended up with were, flavors of Cosmos DB. So that basically became the choice. I think the major alternative would be to go for a SQL database, where I think you will have to think of all your data structures beforehand, and it slows you down. Even if it's just a little bit, you can try, immediately to change your data structures on the fly if you're using a NoSQL database. So that kind of made the final decision, I think.
That makes sense. I've heard this from many developers building AI applications that said to make an application smart, you have to iterate fast. And to iterate fast, NoSQL database, they were kind of built for this purpose.
Yeah, I think this is especially important when developing for AI because it moves much faster, right? So if you're doing well, you're going to be trying out ideas from lots of different papers and blogs all the time. And, one less bottleneck to try out things is always great.
That makes a lot of sense. What did you learn through your journey? I think this would be a great lessons for our viewers as they're all on the same journey as you.
Yeah, so I'll touch on that on our session. But what I find personally most exciting is that generative AI is kind of opening up a new, and this sounds a bit pompous, but a new programming paradigm. Yeah, so you move some things from code to language, which changes everything about how you develop. So I would say, for instance, testing, even basic testing becomes different because you have non-deterministic behavior in models. What's a good answer, right? So you have a lot more fuzzy answers in assistants. That's a difficult problem. So lots of new programming patterns. I think that's one thing to watch out for. I think especially relevant for people watching this is retrieval augmented generation, RAG, which I'm sure are going to be featured in a bunch of sessions. And the second lesson definitely would be that this quick iterations, especially if you're doing AI apps, are really important.
Awesome. Thank you so much, Massimiliano. Just to remind everyone, Massimiliano has a session later in the day. Please be sure to tune in. Really exciting stuff. I had a preview. It's great learnings, great lessons for everyone building AI applications all around how do you test, how do you build responsible AI applications. Thank you so much, Massimiliano. So great to have you on the show.
Sure. Thank you.
I would like to thank you, Massimiliano. And I'm really excited about what they're going to build and what they've built today with Azure Cosmos DB and OpenAI. Now, many applications have been built with Azure Cosmos DB and AI together, including ChatGPT itself. Azure OpenAI uses Cosmos DB for all of their user interactions. And there are two reasons for it. One, they chose Cosmos DB as a database that allows them to iterate fast, because to build intelligent apps, you have to iterate fast and change your data shape. And Cosmos DB provides schemaless support. And second, Cosmos DB scales transparently and limitlessly. As you look at this graph, as OpenAI added new capabilities, the traffic keeps growing. Phenomenal growth. More than 100 million users in less than 6 months. And Cosmos DB just transparently was scaling behind the scenes. OpenAI did not have to do anything, did not have to upgrade or do any operations on the database. It automatically and seamlessly scales. Now, this instant auto-scale has been one of the pillars of Cosmos DB for a while. And last November, we announced a new behavioral addition to autoscale, a change that allows autoscale to respect the variability in your traffic. Beforehand, autoscale would scale, just like many distributed databases, would scale all nodes, all physical partitions to the needs of the busiest one. Sometimes that means it scales too much, and you have a lot of over-provision capacity you're not using. With this change, dynamic autoscale, per partition, per region autoscale, Cosmos DB now scales each partition individually for the needs of the application. And it's good for two reasons. One, if you have uneven traffic, you don't pay for the needs of the busiest partition across the board. And if you have added a second region for reliability, for these 5 nines, you don't have to pay for the second region, just like you do with other databases. With Cosmos DB, you only pay for what you use. So that secondary region can be scaled down to close to 0, and you only pay when you actually direct traffic to that second region. Now, multi-region deployments are very popular with Cosmos DB because it offers you this turnkey active-active setup with providing you 5 nines and RTO 0, automatic failover. Many customers are using Cosmos DB active-active multi-region writes capability, including Walmart.com, ABN AMRO. And I'd like to invite into the studio one of our customers, MasterCard, who is also taking advantage of active-active to provide this superior availability and reliability to their users. I'd like to welcome MasterCard to the studio now.
I would like to welcome Siddiq Hamid and Niraj Javia from MasterCard. Welcome to our show. Would you like to introduce yourself?
Awesome. Thanks, Kirill. Yeah, I'm Siddiq Hamid, VP of Software Engineering at MasterCard. So I work specifically at Ethica, which is a MasterCard company specialized in fighting fraud and preventing credit card disputes. So at a high level, what we do, I wanted to kind of quickly give some brief background of my role here, and then I'll hand over to Niraj after that. So at a high level, I lead engineering teams working on Consumer Clarity Platform. So what is Consumer Clarity Platform? Essentially, what it does is it connects card issuing banks and merchants to provide rich purchase information, like by providing recognizable merchant names, logos, digital receipts, and subscription control. And then, again, there's we were going to touch upon a lot more than that. So I'm solely responsible for coming up with the strategy and executing the build work and make sure operationally the platform is fully up and running, and catering to our customers on day in day out basis. Back to you, Kirill.
And Niraj, would you mind introducing yourself and what you do?
Yeah, sure, Kirill. My name is Niraj Javia. I'm Director of Software Engineering at MasterCard. Apart from building new capabilities on the Clarity ecosystem, which Siddiq just mentioned, one of the focus areas is how to make that platform reliable and scalable as we grow. So that is one of my key focus area, and that's where the Azure Cosmos DB comes into the play. So back to you.
Awesome. Awesome. Well, it's great to have you on the show. So maybe we can start with a use case. Siddiq, would you mind telling us a little more? I know you mentioned fraud detection. What do you do and how do you use Cosmos DB in that use case?
Awesome. So it's more of a fraud prevention and credit card dispute prevention, if I can put it that way, right? So Consumer Clarity is a data intensive platform, right? So which we offer really real-time high throughput APIs where we need to perform certain operations in a fraction of a second. So currently, our platform is going at an exponential scale, right? In terms of our API traffic and data volume. Obviously, like we have aggressive SLAs with the customers, and the need for speed is really high. So if I can put it this way, a metaphor I could use here is like think of it like the platform. The need of what we do here is you are looking for a needle in a haystack, not from one room, probably in multiple rooms. Like you're looking for one needle across multiple rooms in those haystack. That's kind of what we do. Like a lot of parallel processing, a lot of high throughput, data intensive, complex data intensive operations we do behind the scene. So how do we use? How do we use it? I would say, if I can put it simply, we are using Cosmos DB at its fullest capacity, in a lot of terms, right? So that's basically how I can define it. So the use case, here is absolutely it's hitting on all the top areas with respect to the speed, resiliency, and such.
Makes sense. And if you would say, what is one capability of Cosmos DB that made it a really good fit for the fraud alerting?
Yeah, I would say, so just to clarify, it's like credit card dispute prevention is the use case, right? Yeah. So I give you three, not one. So for us, high availability, resiliency, and performance throughput are the paramount for the platform success, right? So what we found, Cosmos DB checks off all those boxes and proven to be the right tool for the right job. So in all these things, there is no way we can trade off one or compromise one over the other. Cosmos DB was really helpful for us to pushing all these different aspects to the fullest, and then able to deliver on the solution, make sure we are able to fully function across all our global data centers across all the different regions. So that, to me, all those three are key, and Cosmos DB was able to really help us grow and scale with a really high speed, in a quick turnaround overall.
You can't even imagine how grateful I am hearing you say this, because that is exactly the use cases that we've built Cosmos DB for. And MasterCard, to me, is an epitome of what a highly available and scalable system ought to be, right? I use it, I'm a customer, and I expect it to just work all the time. I expect it to never fail. Yeah. Not exactly. Like 5 nines or 6 nines, any nines. And Niraj, you mentioned you focus on availability and resiliency. How do you use Cosmos DB? And I think Siddiq mentioned active-active. How do you use the Cosmos DB in this setup?
Yeah, so as Siddiq mentioned, our Clarity platform is a multi-region platform. So we need to get the data replication across the region. So let's start with the data ingestion process, right? So we ingest the data, billions of records, and then that need to be replicated, available in other regions. So that high availability kind of plays the big role on what we are offering to our customers across the globe. So that is one of the vital part of our Clarity scale. And the data ingestion process, like 2 years back, we used to deal with the 1 terabyte, 2 terabytes of data, but now it's scaled to double digit of data set, and still able to handle that SLA, with which we have very strict SLA in terms of response time and high availability. That's where the Azure Cosmos DB played a vital role in our success story.
That's really great to hear. That's exactly how Microsoft Cloud uses Cosmos DB as well. These are the type of scenarios where it needs to be global, it needs to just work, it needs to be available always, and enable you to do writes no matter which region you're doing the writes. And so as you do those writes, I imagine given the nature of the Clarity platform and the use case, the traffic is not constant, right? It varies. Do you guys use the auto-scale capabilities? And how useful it is for you. What do you do with it?
Yeah, it's a game changing for us. So let me start with a journey back. When we went live with the Cosmos DB, we were pretty manual scaling. So our high intent jobs like the ingestion part, which takes hours to ingest the data of billions records. And parallelly, we are doing the lookup when the updates are happening. So from manual to the auto scale, which we successfully rolled out last year, it played a big role. One in scaling the platform from 100 to 1000 TPS, but also parallelly executing those complex and heavy intent jobs without manually going and updating those RUs. So that's where I think it played an important role on where we stand today, and also looking forward for the growth which we expect in the near future.
Oh, that's really great to hear, because that's exactly when we were deciding whether to offer reactive autoscale versus proactive instant autoscale. That is a scenario where you don't want to compromise availability to achieve this optimal autoscale, but at the same time, you do want it to save you cost. That's great to hear. And I hope some of those capabilities that I mentioned through our session, like dynamic autoscale, per partition, per region autoscale, you will find a good use for, because it will allow you to scale differently in different regions automatically, depending on the time of day and depending on the traffic. Go ahead.
Yeah, you nailed that. You nailed exactly that point where we are kind of looking forward for that, because some regions we need scale at a different level than the other regions, right? Because the traffic is so fluctuating, depending on the day of a given time, right? So definitely looking forward for that capability, and we'll see how we can benefit from that.
Awesome. I'm really grateful for you guys to join me on this show. Thank you, and thank you for being a customer of Cosmos DB. I hope Cosmos DB will continue to provide you capabilities that do not disappoint you. Thank you. Thank you, Siddiq. Thank you, Niraj.
Awesome. Thank you so much. Thanks for having us.
Thank you. I'm so grateful to see the capabilities that Cosmos DB has built used specifically for the reasons that we've built them for. In this case, MasterCard used Cosmos DB active and autoscale, limitless scale for their use case. Now, we've talked about just some of the capabilities of Cosmos DB, and you'll hear a lot more throughout the day. Please tune in and hear from our engineers and our customers about their stories. You'll hear about vector and hybrid search and best practices with it. You'll hear about the hybrid search and vector search coming into the core API of Cosmos DB at any scale with the superior DiskKNN algorithm. You'll see a lot more advances in elasticity, including burst capacities that are already generally available, including hierarchical partition keys. And yesterday we announced ability to change partition key on your database. You'll hear about our transanalytical capabilities, including full fidelity change feed now in preview, materialized views, and what we announced 2 days ago, Microsoft Fabric Mirror for Cosmos DB that allows you to mirror in near real time, mirror your data in Fabric and perform joins across your data in Cosmos, in SQL, and other databases. There is so much more that I have to tell you. Please tune in to the sessions during this day, and I really hope you like our conference, and thank you for joining us today.
Thank you so much, Kirill and Masi from TomTom, along with Siddiq and Niraj from MasterCard. That was such a great keynote. It really feels like we're in the future, right? This past year, we've learned so much about AI applications, and we hear from TomTom how they integrated with the Python SDK super early on for prototyping, and then we're able to actually just make it into production without much anything, really a lot of changes, structural changes. And that's really a testament of how scalable Cosmos DB really is. It makes it just so easy for customers to integrate. We also heard from MasterCard how they're using autoscale, right? That's just another great feature of ours. And we're really investing, and Cosmos DB is at the forefront for a lot of AI applications today.
Yeah, I think a really great example of that is ChatGPT, like Kirill mentioned. We can all remember last March when ChatGPT essentially blew up.
Yeah.
And everyone was on it. Everyone and their moms wanted to try it. And it's super nice to know that that was all powered, the high scalability was all powered by Cosmos DB. So if you need a real life example of how powerful this database is, I don't think there's a better example than ChatGPT. So that was really awesome to hear. And I also wanted to point out, I heard something that Carol said about change partition key now being available. So that is really awesome. I know a lot of our customers have asked for it. And that's like, I was like, am I hearing that right? That was great. So super excited to learn more about all the features and all the different companies that use Cosmos DB. We have so many more talks to come, but firstly, we also want to hear from our audience. So make sure you share on socials with hashtag Azure Cosmos DB Conf and interact with us via chat. We have William, Andrew, and a bunch of other moderators are helping us answer any questions. So staying with this AI theme, let's hear from Azure Cosmos DB Product Manager James Codella on how to build generative AI apps with Azure Cosmos DB.
Hi everyone, I'm James Codella, a product manager in Azure Cosmos DB. Today we're going to be talking about how to build generative AI apps using your data stored in Cosmos DB. So as you probably already know, Cosmos DB is a set of highly scalable and AI-ready databases. We have Azure Cosmos DB NoSQL that features high elasticity and instant autoscale, very low latency, and mission-critical reliability. We're building vector search into the database, and this is going to be launched in preview in May. Today, in Azure Cosmos DB for MongoDB, which is our dedicated or provisioned compute and storage offering, you're able to store your data and vectors together today using built-in vector indexes like IVF and HNSW. I'll talk a little bit about these both today. First, let's talk about some generative AI use cases that we're seeing customers implement with Cosmos DB. First, they're using Cosmos DB for MongoDB as a vector database, right? Storing vectors and data together for consistency and leveraging the flexible schemaless NoSQL orientation of the documents stored in Cosmos DB. We're also seeing a lot of customers do RAG, retrieval augmented generation, trying to find the most relevant data in the database and bring it to ground their large language models to their specific scenarios. We have thousands of customers also using Cosmos DB to manage their chat histories. So logging the user prompts or questions and the responses from the large language model. And this allows you to leverage it in multiple scenarios like conversational context. The chatbot remembers what was talked about in the last session or last day or last week. You're also able to mine these for user insights, identify ways to improve your user experience, leverage the data for fine-tuning and optimization or meta-prompt engineering of your large language models. And also it's important to keep these for auditing purposes. You know, you have your AI models interacting with humans. You may want to make sure that, that the model is behaving as you expect. Finally, we see a lot of customers also doing what's known as semantic caching. And this is leveraging vector search on your historical large language model responses. And this is a really great feature that allows you to save calls to your large language model. And therefore, you're reducing latency and saving LLM costs because you're doing vector search to find the most relevant previously generated responses and leveraging those. So I mentioned that today we have built-in vector search into Cosmos DB for MongoDB. And in May at the Build conference, we're going to announce Cosmos DB NoSQL vector indexing and search. And this is going to be powered by DiskANN, which is a suite of very powerful indexing algorithms that have been developed at Microsoft Research that utilizes both an in-memory index and an on-disk index for efficient querying. This algorithm is made for Cosmos DB infrastructure and allows you to perform vector search at incredible scale and incredible performance. Below, I show an example of how you would execute vector search in Cosmos DB NoSQL query, and it's very simple. You just write a standard query, and we introduce a new system function called vector distance, where you can specify the property to point at that contains your vector embedding in your document, and the query vector that you want to compare against. Really simple, really easy to use, and we'll be announcing this at Build and showing some demos at the end of May. Now, that's enough slides. Let's get into a demo. So I'm going to walk through a Jupyter Notebook where we're building a RAG pattern application in Python, and we're going to leverage Azure Cosmos DB for MongoDB. Okay, great. So let's take a look at this Jupyter Notebook where we're going to build a RAG pattern application using Python, LangChain, and Gradio to have a really nice interface up and running very quickly for my chatbot. So we're gonna be using the movie lens dataset, which contains some descriptive information about lots of different movies, and we will be building a chatbot that will help us ask questions and learn about different movies and different characteristics of movies. So in this notebook, we'll start off by installing the necessary packages that I'll be using through this demo. So I've already gone ahead and done that, so I've commented those out. And I forgot to mention that this notebook will be available in some links that I'll share at the end of the demo. So don't worry if I'm running through this very quickly or there's some blocks of code that look really verbose. You'll be able to access this and all the data afterwards. Great. So I'll import the packages that I'm using. And again, really using a lot of LangChain, Gradio for the interface, and also PyMongo to access my Cosmos DB for MongoDB resource. So we'll let that load up there. And once all my packages have finished loading, it's a little bit slow, but that's okay. I'm running it locally. So once my packages have finished loading, then I'll start loading my environment variables, right? So I have an environment file that contains all my connection info for my Cosmos DB for MongoDB resource, as well as all my connection info and deployment info for my OpenAI embeddings model and my OpenAI completions model. This is my GPT model that I'll be using for my chatbot. Then I'll go ahead and connect to my Cosmos DB resources. We'll go ahead and execute that one. We'll go ahead and execute this cell. And now I have some shortcuts to my Cosmos DB collections and databases. I will instantiate connection to my embeddings model here, and we'll give it a test, right? We'll pass this test string into my Azure OpenAI embeddings model, and I'll get back a text3 large embedding. So this is a vector embedding that was created using the newest OpenAI model that was recently deployed on Azure. So not really that useful just to look at, but kind of cool to see. Next, I will set up a vector search pipeline with LangChain, right? So I'm basically connecting to my Cosmos DB for MongoDB resource and providing some connection string details and some information about what vector properties to use, etc. So I'll go ahead and set that up. And optionally here, if I haven't already uploaded my data and created a vector index to allow me to do vector similarity search, I can go ahead and define an index or create an index here. I've already gone ahead and done this, so I'm going to skip the step. And now, I have my connection set up to my Cosmos DB database with all my data and vectors already in there. I have my vector index defined. I did that previously. And now we'll do a test vector search. So I'll say, I'm going to search for movies and descriptions of movies that contain the something semantically similar to Buzz Lightyear. And I'm going to ask for the top 5 results, and I'm giving it a similarity score threshold of 0.2 because I just want to see what else is in the data set. So I'll go ahead and run that. And I can see 5 documents came back just as I requested. And then these are the descriptions or overviews of movies. So it sounds like these first 3 are Toy Story movies, which is cool. That's exactly right. And it looks like these last 2 maybe aren't Toy Story movies, but they're Pixar movies, right? They're referring to Lightning McQueen, who's a character in the Pixar Cars series. So it's interesting that I was able to find, Toy Story is the most semantically relevant, or Toy Story movies are the most semantically relevant based on the descriptions. And these other Pixar movies are also somewhat relevant as well. So that's pretty cool to see, and a good indication that my vector search is working properly. Next, I'll start setting up my large language model pipeline using LangChain. So what we'll do is we'll first set up a prompt. These are instructions that I want to give to my large language model and how to respond. And I'm going to be preparing a LangChain chain or a sequential series of steps, doing a couple things, right? So I'm going to set up my vector store as my base for getting information about my movies. I'm going to set up a large language model connection to my completions model in Azure OpenAI. This is my GPT model that I've deployed. Then I'm going to set up this built-in LangChain object called conversational retrieval chain. And this allows me to do cool stuff like get data from a data store, Cosmos DB, feed it to a large language model in Azure OpenAI, and do things like semantic caching, leveraging previous responses instead of calling my large language model all the time, and store conversational history in Cosmos DB. And this is going to help me do this fairly quickly. So there's a lot of verbosity here. Again, you can refer to this in some of the GitHub links that I'll refer to at the end of this demo. So I'll go ahead and execute that. And then I'll load up my, my examples here. And what we'll do is we'll just clear everything, make sure it's nice and clean. And let's run a test, right? So I'm going to invoke my large language model through the chain, and I'm going to ask it a question. Tell me about movies with Buzz Lightyear. And so this will execute the vector search and send it to my large language model. And it says, hey, there are 3 movies that feature Buzz Lightyear: Toy Story, Toy Story 2, and Toy Story 3. Now notice that took 3.35 seconds. Most of that time is spent because of the GPT model taking time to generate completion. Now, that question and the response have been stored in my semantic cache in Cosmos DB. Now, when I run the same question or a similar question again, I can see that the wait time is much shorter, not even 500 milliseconds, right? And this is because it doesn't need to execute the large language model call. It leverages the previously generated response stored in Cosmos DB, and all it does is a simple vector search for retrieval. And I can save, almost 3 seconds off the clock. So really cool, really powerful, saves time and money. Now that I have that simple demo set up, let's go ahead and set up a cool UI with Gradio. So I have some Gradio commands set up here, and I have my simple interface set up. So I'm going to go ahead and execute this cell, and this will set up everything for me. And then I'll go launch a demo here, and I'll create a little local server. And I can see in VS Code that I can see my Gradio interface. It doesn't particularly look that appealing in VS Code, so I'm going to go ahead and click on this link, and I'll bring over my web browser here. So here we go. I see my chatbot interface and my cool little web app, and I can say, hello, tell me about movies that have Captain Kirk. And so we'll run and do the vector search, get the relevant documents, and feed it to the large language model. And it tells me about these Star Trek movies with Captain Kirk. And I can even ask more detailed questions like, what movie had whales in it? I think it was one of the Star Trek movies, right? And hey, Star Trek 4, The Voyage Home. And that's absolutely right. So here's a really quick and easy way to get started with a Python application using LangChain, Cosmos DB, and Gradio for your interface. Now, I promised you a couple resources at the end, so let's take a look at those. Cool. Yeah, so a lot of resources that you can take advantage of. We have AKA MS quick links, so you can go read more about Cosmos DB and LangChain, including the vector search capabilities. We have an article specifically on using semantic cache with Cosmos DB. And then we also have integrations with Semantic Kernel, which is a Microsoft-developed LLM orchestrator. We have integrations with Azure OpenAI Studio for a low/no code environment to get started with a POC right away. And we also have solution accelerators in .NET and in Java to get you started. So go ahead and check out some of these resources, and this will be a great way to get started with a demo and get started using Cosmos DB for MongoDB's vector search capabilities. Thanks.
Thanks, James. It was super cool to get a brief crash course on vectors. I really love the demo on RAG patterns, especially in Python. It makes it super duper easy. I think we should probably create our own little chatbots for personal use.
Yeah, it was also super cool to hear that we have so many updates coming to the feature in May for Build. So if you guys don't already have it on your calendars, please tune in to the Azure Cosmos DB sessions during Microsoft Build, because there's some really exciting stuff on the way that James mentioned, and probably so much even more that hasn't been mentioned yet. So let's also take a look at
what are people saying on socials. I want to give a quick shout out to Peter watching from New York, Ben from Australia. I wonder what time is it out there. Fitsum from Ethiopia, Srini from India, and everyone else on the chat.
Another tweet we just got, we have Tomohisa, who said change partition key is a really nice feature to have. So lots of excitement about the new features that we have, especially this one. So go ahead and check it out if you haven't already. Next up, we have Michael John Pena, who is a data and AI director from Playtime Solutions, and he's also a Microsoft MVP. He has a talk on how to make Azure Cosmos DB part of your AI applications.
Hi, everyone. I'm here to talk about Azure Cosmos DB as a vector database. My name is Michael John Pena. I'm a Microsoft Azure MVP and a data and AI director for Playtime Solutions. So why do we need to talk about vectors, right? And in particular, Cosmos DB as vector database. So in your journey towards large language models, generative AI, and Copilot, we created this hierarchy called the Copilot hierarchy of needs and wants. When personal exposure is about just checking out ChatGPT, Copilot, and stuff like that. Group consumption is when the group started to look at these tools and use it for their businesses. And it's really when you get to this connected data, when you want to explore, how do I connect my own data to this new technologies, these new generative AI technologies, right? And with that, you have a concept of something called an RAG, or retrieval augmented generation, right? Where in your application talks to a server and talks to an indexer of some sort and stores and retrieve those vector embeddings, right? We'll talk more about that in a few. And when you talk about vector databases on Azure, there isn't any native solution out there. When we talk about native, there's no such thing as Azure Vector Database product out there. The only way to host native vector databases out there is to use things like Azure Container Apps, Kubernetes, or virtual machines. However, if you want to use or leverage a NoSQL approach, you can use something like Cosmos DB and Redis. And if you still want to use SQL, you can use Azure SQL and Postgres. But then if you want to do it in a point of view of performing search, you can use something like Azure AI Search. So that's why when you're in this vector database journey on Azure, you might need to use a different set of tools depending on which one to use. In particular for Cosmos DB, there are actually 3 options out there, right? So the first option is to use an Azure AI Search via an indexer. This is a no-code solution. And the second one is to use the MongoDB core capability of Azure Cosmos DB, basically leveraging MongoDB's capability as your vector storage. And lastly is to use Postgres with a Citus extension so that you have that global scale. And at the same time, the most important bit is using pgvector extension to allow a more native capability of storing vector embeddings. Let's start with the AI search journey. So with AI search, all you gotta do is that because you're doing it in a point of view of search, all it needs to do is just retrieve a bunch of data. In this case, something like Cosmos DB is a data source. And then there's some series of events such as the data cracking, enriching, and capabilities around embedding things like using Azure OpenAI's ADA 002 embedding model to do all those operations for you automatically, right? And then with that, all of those embeddings from your data source are now actually stored in Azure AI Search. So that means that the data from your source eventually gets converted as an embedding in a vector representation and stored in AI Search. And from that point forward, an application such as a web app or a backend or a mobile app can now communicate through your data using AI Search. So to put that in perspective, all you gotta do is in AI Search, add a data source. And in that adding of data source, you just have to select a database. And in this case, that's going to be Cosmos DB, and perform some data field mapping, right? And just continue throughout the step, and you'll have an easy, ready-made connection for you. To show you how it looks like, on my right, I have a Cosmos DB called Cosmos NoSQL Vector. And in that, I have a database called Vulkan DB. And with that database, I have a volcanoes collection, right? So this is just a bunch of volcanoes out there that you can actually kind of like, it shows the name of the volcano, the country of origin, and the region, and some other types like elevation, type, and status, right? So I've already performed a bunch of queries in Azure OpenAI. And with that, I first start asking, can you list down all the Japan volcanoes, right? Or at least most of the Japan volcanoes. So he was able to list it all down, the Fuji, Kujin, and stuff. Same goes with USA. And I even asked about the Philippines. So in this case, for example, with Arayat, the data that was presented here in Azure OpenAI was actually representative of the data uploaded in Cosmos DB. So you can see a like-to-like comparison that it's a stratovolcano, which is of that type, and the elevation is 1026 meters, right? So with this approach, this allows you to have a large language model capability without having to update a model frequently, right? You can just base it off from your own data anytime. Now, I want to talk about MongoDB Core, right? So the beauty of Azure Cosmos DB is that you have a lot of options out there to use different set of technologies, and it's already scalable in a way that it's globally accessible. And just adding these capabilities of vectors is just like adding a new data set or a new data type, right? So it's not the way you provision the infrastructure, the way you interface with the application would still be relatively the same. It's just that you are introducing this new set of services and capabilities. So I have a sample code in here wherein it's a Python notebook wherein I'm interfacing using PyMongo. So in here, I created an index called Easy Test Index and a collection, which is Easy Test Collection. And in this case, I'm using Azure OpenAI to create that embedding capabilities for us, right? And in here, I'm also using something called LangChain to perform the chunking or the separation of a document for me, right? So I have a document here called pradapi.txt. It's basically a collection of services in Azure about data analytics, right? So I talk about Fabric, Databricks, and Data Factory and pipelines. So when I go back here, all I'm doing here is that, hey, try to ingest all this information from that text file and use the Azure OpenAI embeddings, which is, again, the ADA002 model. And from there, I want to connect to the MongoDB cluster that I provisioned using, again, MongoDB Core, very important distinction out there. And from there, all I'm doing is that I'm creating this vector store that all those documents that I'm trying to kind of like embed or chunk and slice it up, I want to put them to that Cosmos DB. And as part of that, I need to create an index as well. So from there, I can now perform a similarity search between embeddings, right? So when I perform a query of Microsoft Fabric features, it can perform that similarity search to actually search that in which part of the document it mentions Microsoft Fabric features. And in this case, it did pull up that, hey, when I was talking about Microsoft Fabric, it did pull up that section. And furthermore, you can also now perform a similarity search between a query and the ingested document as well. So what that means is that Cosmos DB is now acting something like a caching layer for you, so that you don't have to retrieve or perform those embedding operations all over again. And to look what's inside the database, if I open my database, you can see that if I try to find all the collections in that Easy Test collection, all the documents in there, you can see that all of these embeddings that LangChain created for us are now in here. Here's the text content, and the vector content are in here on the right. So with that, you can actually leverage the Cosmos DB, MongoDB Core capability as your vector database, right? Because at the end of the day, a vector database is just a storage of all these vector contents, right? Like, and all it does is that it performs a bunch of similarity algorithms to know that when you're performing a query, it converts to vectors and tries to compare that to the vector content in that database. And that's the whole point of vector database we're in. It's about how accurate and how similar a search result could be. Okay, now let's move on to Postgres. Postgres is one of the most loved database out there. Arguably, it's probably not just a SQL database anymore. It's already a database that can support a lot of different things, right? And if you put it this way, Postgres was created before MongoDB, but then during that time, a lot of the capabilities of MongoDB was also imbued in Postgres, such as the global scaling capability. And hence, with Azure Cosmos DB, it have that Citus extension that allows you to have a globally scalable Postgres database. And now, with something like pgvector, you can actually integrate vector embeddings as well in that globally scalable Postgres database. So to see that in action, let's go back to VS Code. In this case, it's a bit different. What I did here is that I'm using scopg. So it's an extension within pgvector that allows you to utilize different vector capabilities in Postgres, right? So first off, I need to do all of these imports and set up my database here. Just so you know, and it's very important for those who want to explore this up, that you need to use the Postgres SQL prefix, not the Postgres prefix for this to work. Then I'm just generating a random data here, right? And all I'm doing here is that first I need to create the extension vector. So pgvector is called vector as an extension. Then if this vector extension doesn't exist, it's first going to create that. And then after that, I'm just creating a table called vector documents. And within that, after creating the vector documents table, I'm just loading a bunch of random vector data out there, right? And it's just I just want to show that loading million rows, it only took me around less than 2 minutes, right? Which is a very powerful capability of Postgres on Cosmos DB. And with that, I just exited and made sure that the connection is clear for good measure. So to see what's out there, so if I go to the vector database here on the left, in particular, the Postgres database. So you can see, first, I want to show that I'm connected to the Citus database of Postgres, again, on Azure Cosmos DB. And then, in particular, I want to look at in public and in database objects. I want to look at the extensions, right? So in extensions, you can see there's the Citus extension. Again, that's what powers this globally powerful Cosmos DB database. And again, in that topic of vectors, you need to make sure that the pgvector extension, aka vector extension, is installed. So from there, the one we just did earlier, they are actually stored in a table called vector documents. And in that vector documents, we have a bunch of different random embeddings data for you. And there you go, right? Like with this approach, you can use Postgres as well as your vector database. So that's it. Thank you very much for listening. And if you want to learn more, you can go to these websites. You can add me on LinkedIn or email me. Thank you very much.
Awesome. Thank you so much, Michael, for another great session highlighting Cosmos DB and vector databases. I also really liked how he talked about AI search and integrations with other Azure services.
Yeah, it's just awesome to see how many cool functions we have for AI, and I feel like we've been saying that throughout the whole
it's been the theme,
today.
really.
It's been the theme, really. So yeah, thank you so much, Michael, for that awesome presentation. Let's check in on our socials. I see that someone here has posted their speaker swag. So if you guys are interested in giving a talk for next year, this is probably you could get some really cool stuff. I see a Stanley Cup here, which is pretty hard to get your hands on these days.
Definitely.
Yeah, that's really fun. Thanks, Marcelo, for posting that, and keep it coming as well. We definitely want to hear how you guys are liking this, and feel free to drop any questions that you have in our chat. We have Andrew and we have William there to help us answer any questions as well. We have plenty of more talks on the way, but first let's hear from Rishi Gupta, who's a senior cloud architect at JetBlue.
Hello, my name is Rishi Gupta. I'm Senior Cloud Architect at JetBlue. Single digit response time. I mean, it's not the single factor, but that is the most critical from the latency perspective, and of course the global resiliency. Very good question. As a preferred AI database functionality like native vector search or seamless integration with Azure AI services to support the retrieval of augmented generations, our app development get pretty faster, and it's a game changer, and going to be more, right, when we are integrate all of our AI things with the Cosmos DB.
Thanks, Rishi. Just to vamp on how amazing it was that Azure Cosmos DB is part of your day-to-day life without even realizing it. Like when you're booking a flight on your JetBlue app, for example, and all of that is being powered by Cosmos DB on the back end. Isn't that crazy?
Yeah, it's so cool. And we heard about MasterCard earlier today. So if you're using your MasterCard to book a flight on JetBlue, that's already using Cosmos DB twice in the day. Awesome, yeah. So next up, we have Jasmine Greenaway from the Microsoft Data Advocacy team, and she'll be talking about how Azure Cosmos DB, the best practices for the design patterns, and then that'll be followed by Tina from JP Morgan Chase, who will be demonstrating how to build eventually consistent applications on Azure Cosmos DB.
Hi, I'm Jasmine, and I'll be walking you through design patterns in Azure Cosmos DB. We'll talk about what makes them so great, and then we'll categorize them into 3 particular categories, and then we'll apply those to particular design patterns in Azure Cosmos DB, where we have a really awesome repository that covers all of the design patterns that the team has been writing about. And then we'll get into 2 particular demos that kind of focus on 2 different design patterns across 2 of these particular categories. Now, design patterns are nothing new. We use them to solve common problems that we as developers face. And they essentially help us build reliable and maintainable software that really stands the test of time. And, in this vast universe of design patterns, when we think about them, we're often thinking about software construction and software development. And we can really break them down into 3 particular categories: creational, structural, and behavior, where creational is focused on things like object creation, where we want to create them in a manner that is suitable for a particular situation. One really popular one is the singleton pattern that allows us to maintain an instance of a class to make sure there's a single point of access and entry, as well as a single point of failure, in which this actually helps us maintain behavior and resource management. And then let's get into behavioral. This is really around algorithms that deal with the assignment of responsibilities between objects, like the observer pattern. That's another popular one, where one object is responsible for notifying any dependence of any changes and changes in the software, and it's often used in things like distributed event handling, where state consistency is key and is important. And finally, structural, where we focus on how objects are composed to form larger structures, like the adapter pattern. This essentially bridges incompatible interfaces that are often used in things like new features and components, and things that are essentially introduced into an existing code base. And when we think about data architecture, we can apply these same categories. So in again, these same categories, structural patterns really apply to how the data is organized and stored and accessed. Creational focuses on the dynamic creation of these schemas, where dynamic creation is really a big key point in NoSQL architecture. So things like tables or containers, indexes that may change over time, and these are really focused on an application's need. And then finally, behavior, where we focus on how the data is accessed and manipulated and how those changes are actually propagated throughout our data set, throughout our container, and throughout the items within it. So as I mentioned before, Azure Cosmos DB has a design patterns repo that kind of focuses on all these particular ones here. So between structural, creational, and behavioral, and they're actually a repo that kind of illustrates in code how these all work. So from attribute to array to materialized view, we can see there's one right now on creational called pre-allocation, behavioral like distributed counting, document versioning, schema versioning. Some of these you might have heard before and can actually also be applied to other NoSQL architectures outside of Azure Cosmos DB. So with that, the moment you've been waiting for, we're going to get into two particular demos. First, we'll look at the structural type called attribute array, and then we'll move on to behavioral under distributed counter. So I'm going to go ahead and move on to my repository here. And just want to show you the Cosmos DB design patterns repository. It has a bunch of information about these particular design patterns, how to apply them, especially also how to apply or how to use the demos within them. So first here, the attribute array is really focused on working on multiple name value pairs that have similar data. And what we want to do is really turn these into arrays and actually make them part of the parent object. Now, the benefit of this is that it makes querying a lot more easier, and it also allows us to make it a little bit more performant and essentially efficient to index, and makes our queries also a little bit more concise. So in one particular situation, think about when you have an e-commerce store. Maybe you have a particular product that has three particular categories. So for example, shirts that come in multiple sizes, small, medium, and large, and so on and so forth. So you could, a whole range of shirt sizes. And let's kind of walk through the documentation here. So so here's like an example of like kind of what that data could be modeled like in like essentially like, for example, a database schema. And this is what it would look like in Azure Cosmos DB. We have this particular shoe product that is broken down into small, medium, and large, and we can see that this can be a little bit of a challenge to query. So look at this, look how big and complex this query is. But what if we were able to essentially massage this data and make it into essentially a set of arrays? Specifically, these sizes get turned into arrays, and then we can make this into a more of a cohesive and more flexible query. So let's take a look at what this looks like in our code. So I'm actually not going to get into the code in particular because the demo code essentially creates the collection for you. But what the code actually does is it allows you in the command line to see kind of what the data that's being stored in your NoSQL database looks like. So for example, here I have this one product called an ergonomic plastic mouse, and maybe I do know that mouses do come in different sizes. So maybe we do have a set of small, medium, and large mouses for our customer base. And here we can see that we can take a look at also the some additional products here or some additional massaging of those products to really reshape this collection into this attribute array pattern. So what I'm going to do is actually take a look at this in Azure Cosmos DB Data Explorer. So let me just show you what a particular item looks like. So let's take a look at that same mouse. And we can see that we have this very, I wouldn't say inefficient, but one way for us to really describe these mouses and these sizes. But what if we were able to apply this with the attribute array pattern? So let me find that here in the list here. So we can see that what all the attribute array pattern really does is allows us to change the structure of our items so that we can easily query and break down these particular sizes break down these particular items or attributes into particular categories. So let's take a look at some queries here. So as I showed you before in the repository, we have this really complex query where we're getting all of pulling all of the items from our collection. And here I'm looking for items that have a query or a quantity of 75 or greater. So let's see if I run this. And let's see if I can open this up. We can see here that I have my ergonomic plastic mouse, and I can see that it's actually pulling in all of my items. So this will require maybe a little bit more massaging to really get what you need, but either way, it's going to take a lot more work to actually pull out the items that actually have 75 of a quantity or greater, which would in this case be medium and large. So even if I did something like this, so like say that I commented out this and ran this again, see I run to an issue and all kinds of things. So let's actually move on from this and take a look at, I'm going to comment this out and let's take a look at a different way to really run this query. So let me uncomment this and let's go ahead and get started. And so here we go. First thing you can see is that this query is actually much smaller. And here we can I have my count and I join my products item with my sizes, and then I go and I find everything within that sizes array that has a size of or a inventory of 75 or greater. So let me go ahead and run this and execute this query one more time. And there we go. And now we can see this is actually returning our objects our mouses with the proper quantities and the sizes to match. So that's great. So again, this is something that you can try out yourself in the repository. Now we're going to go to a little bit more of a complex design pattern called distributed counter. And this is what this really is for when you're doing things like real-time updates. So say that, that same product, that mouse product is really flying off the shelves. How do you manage inventory so that you don't run into a situation, or the user or a buyer doesn't run into a situation where they might have an incorrect idea of how many mice that they can actually buy. So the idea around this is, essentially creating these multiple distributed counters using the value of one primary counter. So this counter essentially splits off into multiple counters to really manage the number as well as the value of these counters at any given time. So there's a lot more that is going on here, but the idea is that it's supposed to prevent you from running into situations where you might have issues with concurrency, and also allow you to be able to find how many items you have left in any particular given time. So we're going to go ahead and run this simulation of distributed counter. And this particular counter is a .NET application that has a Blazor front end that allows us to really see these counters working in real time. So what I'm going to do is I'm going to actually hop into our distributed counter demo here. So here's our little application, and I'm going to go ahead and create the counter. And now I have my counter here, but notice that this is and here is essentially my primary counter. This is a counter that holds my initial value, and then this is going to be split off into these multiple counters. So what I'm going to do here is copy this ID, and then I'm going to hop into my application here and do .NET run. And this is what's going to essentially simulate those counters for me. So let's go ahead and just give this a second to run. And that counter ID I copied, I'm going to paste it right in here. And we're going to say, let's say that we do, I don't know, 5 worker threads. And now we see all of our threads running. And if I take a look here, we can see all of our threads here working across this visualization. And here we can also apply the idea of like splitting or merging these counters. And what's good about these is that like if you need to split a counter, you can essentially meet the computational load of maybe more people coming to get to buy your items, or merging them to scale back these counters when the demand dies down. So this is another really great demo that you can try yourself as well. And again, these come with full sets of instructions on how to use them yourself and how to get started. So going back to the slides, we're going to wrap up here. If you want to try this yourself, like I mentioned before, you can go to aka.ms Cosmos DB design patterns. In there, you will find, actually, this link here actually refers to actually a blog series created by the product team that kind of goes into depth on what these design patterns are for and how to apply them and why you'd want to use them, as well as references to the actual repository that walks through these in detail and through code. So I hope you give it a try, and thank you so much for coming to this session, and I'll see you online.
Hello, everyone. Welcome to Azure Cosmos DB Conference 2024. My name is Tina Adnani, and today I'll be talking on building eventually consistent applications with Azure Cosmos DB. Now, whenever you talk about building distributed systems, there are different quality attributes that we commonly try to achieve in modern software architecture design. We want it to be cloud native, we want to build reactive systems, it should be scalable, high performing, should have high availability, low latency, and then on top of it, we want loose coupling, agility, so on and so forth. Oh, and I forgot, cost efficient, right? But ultimately, we want to build these resilient systems that can withstand surges, failures, and attacks without compromising on data integrity. But what we need to understand is that getting these quality attributes in your application is not an easy job. There are challenges. Let's understand this with a scenario. Let's imagine we are building an e-commerce site. So we have a customer who places an order, and for that customer, we need to generate an invoice. There are other components as well, like delivery, payment, notification. But for now, let's only talk about how these two components can be connected. Now, in this first approach, which is orchestrated request-based pattern, after a user places an order, we save the order details, and then we send that order to an invoice service to kick off invoice processing. Now note how tightly coupled both these services are, and the order service, it attempts to orchestrate that entire distributed transaction. And as you see, this process introduces latency and an additional responsibility on the order service. Let's try an alternative approach. In this, we'll decouple the order processing flow from the invoice creation. So after a user places an order, we simply save the order details in the order service. And then rather than immediately trying to create an invoice, we instead have a background job or a process that periodically checks for new or updated orders. And when it finds them, it asynchronously creates or updates the corresponding invoice. So by decoupling these two steps, which is order fulfillment and invoice processing, we reduce latency, for the users which are facing the order service, and they get a happier experience placing their orders. However, this approach introduces delay or temporary inconsistency before invoices are created for new orders. Now let's go a step further and make this an event-based pattern. So in this event-driven approach, like the earlier one, we move away from direct service-to-service communication. But the difference here is that each service, it emits events that others can listen or react upon. So for example, when a user places an order, the order service saves the order details and it emits an order created event onto the event stream. And the invoice service is essentially more like subscribing to these order created events. So when it receives an order created event, it uses the order data to create a new invoice record. Now, this has some good advantages. First, you get independent scaling of each service because they are no longer tightly coupled. Services can be added or updated to handle new events without disrupting others. Also, because each service, it's doing its work asynchronously in parallel, so you get performance advantages. And even from an operational perspective, this approach provides a full audit log of the state changes via that immutable event stream, which can simplify debugging and also allow rebuilding projections. So far, so good. You're getting performance, you're getting scalability and availability, but there is a trade-off. And that trade-off is eventual consistency, that there will be temporary disparities between orders and invoices until events are processed. And in this session, we are talking about how to deal with eventual consistency while building these distributed systems or event-driven systems using Azure Cosmos DB. Yes, Azure Cosmos DB makes it easy to build highly responsive and scalable apps with flexible consistency choices. So first, let's talk about some key features about Azure Cosmos DB. It's globally distributed, enables you to replicate your data across multiple Azure regions worldwide, also ensures low latency data access for the users. Then you have multimodal APIs. So Azure Cosmos DB, it supports multiple data models like document data, key value pairs, graph data, columnar data, all within the same Azure Cosmos DB account. You also get automatic and instant scalability. So Azure Cosmos DB, it offers virtually unlimited and elastically scalable throughput across any number of Azure regions with no application downtime. And you get guaranteed high availability in the event of regional outages. Now, coming to consistency models in Azure Cosmos DB. So one of the cool things about distributed database platforms is that they are no more what they used to be a decade ago. Like earlier, we just used to have two consistency levels, strong consistency and weak consistency. But you know what I love about Azure Cosmos DB is that they have 5 consistency levels. And when I was starting to explore Azure Cosmos DB, I was so excited because I had many different use cases wherein I used to hack around consistency. And I was like, this is so cool. So coming to consistency levels, you have 1, a strong consistency, which means that if you have a write and you do a read, no matter where you are basically going to get the last write. So you lose nothing. Then you have bounded staleness. It means that you're always going to lag a little bit behind your writes. And you can lag either by number of commits or by time, let's say 5 or 10 milliseconds behind the latest. And then the third one, session consistency, the most popular one of all the 5, I'll guess, because let's understand this with the scenario. Say you went on Amazon.com, you added your review, and you were able to see it immediately because they give you session level consistency. However, if someone else goes there and looks for the same review comment that you added, it might not be there for, let's say, another 5, 10, or 15 seconds. And that's okay because you're using session consistency, so there's a trade-off. Then you have the fourth one, which is consistent prefix. And as you can say, the name automatically states that there's going to be some kind of ordering. And this is exactly what it is. Basically, it is that you may be behind, but you will never be out of order in terms of consistent prefix. And then you have eventually consistent. Now, in this, you can be completely out of order when you're doing reads. And it's fine because it's the loosest consistency, but it's also the least expensive in terms of throughput. And that's why it's called as eventual consistency. One more point that I would like to call out here is that Azure Cosmos DB, it provides these tunable consistency levels on a per request basis, allowing engineers to balance latency, throughput, and consistency as per application needs. Now, let's also talk about how can we change the consistency model using our SDKs. Again, a couple of points to note here. One, you cannot increase the strength of the consistency model used. So let's say if you are using session level consistency for your application and you want a strong consistency for a particular request, you can't do that. So only thing that you can do is you can reduce the consistency model. And then the question that comes to mind is, why would you do that? And there is actually a very good scenario for this. So let's say you've got a workload which is using strong or bounded stainless level of consistency, and you want to spin up a new instance of Cosmos Client, and you want to ingest a whole bunch of data and do it rather quickly. Now, if you're using strong consistency, your latency is going to be quite painful because you have to ingest a whole bunch of data and then do it quickly because it's going to commit first to your write region and then to all other regions before coming back. So your latency is not going to be awesome. But what you can do in this scenario is when you're creating a new instance of the SDK client, you drop the consistency level to, let's say, eventual, as you're seeing on the code snippet here on the slide, and then ingest all your data in that session with eventual consistency. Okay, and your data will get inserted, but because it's eventual consistency, you will not be able to see it right then and there, but eventually it will catch up. Then the second point that I want to call out is that the consistency only applies to the read parts here. So when we say consistency, it is that guarantee, right? So where that guarantee is made, it is made on the reads and not on the writes. Only for strong consistency, it's indirectly for writes as well, but for others, the guarantee is made on the reads. So like you saw in this snippet here, once you set the consistency level to eventual, then the next step, what you're going to do is, since you have set your request options to eventual, then when you do a read item async within here, and of course, you're going to pass the ID, the partition key, and your request option, and you're going to get the result based on the consistency level that you have set. Now, let's take a look at some best practices for eventual consistency that you can incorporate in your programming while building your application. I've listed 5 of them here. There are more, but for the purpose of this session, let's look at these 5 in more detail. Number 1, handling inconsistent reads. Now, in an eventual consistent system, you may encounter stale or inconsistent data during reads. So it's the responsibility of your application to gracefully handle these situations. So what are the things that you can do to handle these situations? Like, always query with session tokens so that you see the latest write. So for scenarios like shopping carts, where you need to immediately read the data that you have just written, you can use session tokens because these session tokens will provide a read your write consistency within a session, ensuring that you always read the latest data that you've written. So if you look at this code snippet, what you're doing here is first you're creating an item. It means that you're doing a write. Then from the response header, you pick the session token and you set that up in your request option. And after that, whenever you do the read and you pass in the request option, it ensures that you are getting the latest write that you just wrote in that session. Now, coming to the second point, conflict resolution. So another thing that you can do when you have multi-region write is to handle conflict resolution. Now, why is that necessary? So with multiple write regions, conflicting updates can occur before replication catches up. And it basically happens when writers concurrently update the same item in multiple regions. The good thing is that Azure Cosmos DB provides automatic conflict resolution policies like last writer win or custom. So what you see on the screen here is how you can set the conflict resolution mode as last writer win. And when you set it as last writer win, in that case, it'll take the last writer based on either the timestamp field or, you can call it the _TS property. Then you can also set the conflict resolution as a custom policy, again, as you see on the screen. And when you do this, when you set the policy on your Azure Cosmos DB container, you also need to register a merge stored procedure. And this stored procedure is automatically invoked when conflicts are detected under a database transaction on the server. But what happens when you configure your container, let's say with this custom resolution option, and you fail to register a merge procedure, or maybe the merge procedure throws a runtime exception? In that case, the conflicts are written to the conflicts feed. Your application then needs to manually resolve the conflicts in the conflicts feed. And as you can see in the code snippet, we are defining our own logic for how we want the conflicts to be resolved. Okay, coming to the next point, we have idempotency, a very common best practice. So what is recommended is that you design your write operations to be idempotent, meaning that they can be safely retried without causing unintended side effects. And this is also crucial, when you're dealing with network outages, transient errors, things like that. So again, what you see on this slide is an example that by using upsert item instead of create item, we can execute the same command multiple times without causing changes unless you're making an update. Then you have asynchronous programming, another best practice. So it's always recommended that you embrace asynchronous programming patterns when working with Azure Cosmos DB. So, you can use the async await pattern in .NET or the appropriate asynchronous construct in your language of choice. And yeah, I would like to reiterate that these are some common best practices that you can do while you're doing programming. So do use them. Okay, and the fifth one, coming to change feed triggers. Now, this is really important, especially in building reactive models, because instead of constantly polling for data changes or dealing with, complex synchronization logic, the change feed gives you a reliable stream of all the inserts, updates, and deletes which are happening in your Azure Cosmos DB container. Like, think of it having a live feed of everything happening in your database. So while building applications using Cosmos DB, see if change feed fits the scenario, and if yes, then do build using this functionality. Okay, so now coming back to the scenario that we originally started with, if we were to see how we can build this async pub/sub messaging part, ensuring eventual consistency, how can we do it? So one such pattern you can see that we have created using Azure Cosmos DB, which acts like our persistent data store and handles eventual consistency with respect to the different events that get stored in it, and also replicated for multi-region capabilities. Also see how we have used change feed here. So instead of dealing with complex two-way synchronization, we simply have the invoice service or any other service that you see here consume the change feed from the events catalog persisted in Azure Cosmos DB. So change feed actually acts as a powerful tool for building event-driven architectures where services can subscribe to and react to data changes, decoupling them from each other while still maintaining eventual consistency across the distributed landscape. And this is a Microsoft recommended pattern using Azure Functions and Azure Cosmos DB to build these globally distributed scalable serverless application. So a customer basically places an order in an e-commerce website. The order triggers an Azure function. That Azure function processes the customer's checkout, stores information about the order in Azure Cosmos DB, and that database insert operation, it triggers an Azure Cosmos DB change feed event. So all the systems that are subscribing to the change feed are notified. With that, we come to an end. To summarize, all I want to say is that, remember, we need to design our systems to gracefully work with the challenges of eventual consistency. Like, you have to cater for outdated data, conflicts, potential concurrency anomalies in your data, and events or operations when they come out of order. But even though these challenges may seem daunting, they are manageable if you follow the best practices and patterns that we covered, like using session tokens, change feed, etc. And just to add a little bit of humor to this serious topic, Here is a funny illustration by Pascal Josselin that perfectly captures the essence of eventual consistency. With that, I'm going to leave you with some resources to help you build eventually consistent apps on Azure Cosmos DB. If you haven't tried Azure Cosmos DB yet, please try. It's free without any credit card option. You also find a whole bunch of tutorials and documentation on MS Learn. And if you want to take the specialty path to certification, we also have a special certification for it. And thank you. My contact details are on the slide. Please connect with me on LinkedIn for any conversations on working with eventual consistency in Azure Cosmos DB or distributed architecture or Azure in general. Thank you everyone for watching. Hope you enjoy the rest of the conference. Thank you.
Thank you so much, Tina and Jasmine, for those really informative presentations on design patterns and how to build eventual consistency applications. So a lot of people don't know that Cosmos DB actually supports 5 consistency models, from strong consistency up to eventual consistency, which is what Jasmine was talking about today.
Yeah, it was great to see all the different trade-offs with all these consistency models and how eventual consistency works for her application. So super cool to see that real-life application.
Yeah, and so before we go on to the next presentation, we'd like to hear from you. Show us where you're watching from by taking a picture and sharing with the hashtag Azure Cosmos DB Conf. Are you watching with your kids? Are you watching with pets or anything? I know my friends are having a Cosmos DB watch party at home. Shout out to them.
Yeah, it's awesome. We also have a tweet on our mascot for our conference today. He says, I love the robot of hashtag Azure Cosmos DB Conf, so thank you.
Hashtag cute.
Hashtag cute. And, yeah, the mascot's name is Cosmos. So.
Oh, Cosmo.
All right, let's take a quick detour here to hear from Carlo, who's the CTO of Portnox, and how Azure Cosmos DB fits into their overall application architecture.
Hi, I'm Carlo Zatelny. I'm the CTO at Portnox. I'm in charge of architecture, engineering, security, and DevOps. Azure Cosmos DB is the main data storage for our cloud solution. Not only does it provide the performance and scalability that we need for our solution, but it also allows us to have all of the necessary things for authentication to our customers' devices in their networks worldwide. With Azure Cosmos DB, we're able to support a wide range of devices and configurations from our customers, such that we don't have to change our data model each time something changes inside of our customers' environments. So we get efficiency from our development team that they don't have to change the model each time that our customers' configuration changes. Really, the flexibility of the data model inside of Azure Cosmos DB has been the key feature to allow us to develop features very quickly. And this allows the development team to add features and reliability for our customers in a way that no other database could. Give Azure Cosmos DB a try, aka.ms/trycosmosdb.
Thanks, Carlo. Really glad to hear how much Azure Cosmos DB is part of Portnox, and special thanks for letting people know how to start using Cosmos DB. If you didn't see it, there was a link. It was aka.ms/trycosmosdb. So go ahead and give it a try if you haven't already. I was looking through the chat and we got a really nice comment from Jonas, who said, great show. He's a big fan of both the product and the team behind it. And he has always received consistent and valuable help from the team over the last 9 years.
Wow, almost a decade using Cosmos DB. That's awesome. Awesome. So up next, we've got some more fantastic speakers. First, we'll hear about Microsoft Fabric from Anita, Principal PM Manager for Cosmos DB. And then we'll hear how MasterCard is using Cosmos DB to help them fight fraud.
Hi, everyone. Thank you for joining Azure Cosmos DB conference. I am Anita Adesumili, Principal PM Manager. We are here to talk about near real-time analytics on your Cosmos DB data using mirroring in Microsoft Fabric. In the recent years, we have seen tremendous advancements in AI and generative AI. These bring new opportunities to your businesses like never before. You can build much more personalized customer experiences, look at your business data contextually, and be able to react to events that impact your business in real time. But to be able to do this, you need access to your business data as it is landing, not hours or days later. Analytics and AI is only as good as your data. When we look at your organizations, we see that many of your organizations struggle with data silos. You have departments using different data storage and analytics solutions. It is very difficult to move data across these and analyze it together. We also see tremendous complexity when you're processing this data. You have many services that are put together as bespoke solutions, and it is very difficult to manage security and governance for these. To address these challenges, we have built Microsoft Fabric, a unified data analytics platform. Fabric brings together analytics, AI, and BI solutions under one umbrella. All of these services have the same experiences and same architecture. You will be able to use the one SaaS lake, that is Microsoft OneLake, to bring in all of your organizational data. Once your data lands in OneLake, it automatically becomes available to all the analytics engines without further data movement. The data in OneLake is stored in open source Delta Parquet format, making it truly available to all other services that can process this data. You can set your security and governance one time in one place on Microsoft OneLake. Now, to really bring all of your data into Fabric, we need to provide ways for you to bring this data into the Fabric ecosystem. We have introduced multi-cloud shortcuts in the past year to not only Azure services, but also AWS, GCP, and Dataverse. With shortcuts, the data does not move into OneLake. Rather, Fabric connects seamlessly to these services and runs queries against this data directly. But when we look at your data estate, you still have critical systems such as databases and data warehouses that power your mission-critical applications. These systems are sensitive to performance and latency. And so, to not impact these with analytical queries, most organizations have ETL pipelines where you bring your data into central data warehouse either hourly or nightly. This is highly complex to manage, difficult to put together, and more importantly, you are not getting analytics in real time. We cannot build shortcuts to these data sources because we do not want to run analytical queries directly against these sources. And so, to solve this challenge, we are introducing mirroring in Microsoft Fabric. You can now seamlessly ingest data from your data warehouses and databases into Fabric, into Microsoft OneLake in near real time with zero ETL. Mirroring is now available for Azure Cosmos DB, Azure SQL DB, and Snowflake. We also have Azure SQL Server, MySQL, PostgreSQL, Teradata, MongoDB, SAP, etc. in the roadmap for this upcoming year. Now, mirroring brings all of your data estate together by bringing in all of your data sources along with the data that's coming in through shortcuts, the data already in Fabric. You can now truly unify your data estate. Now, let's see how mirroring works. You can set up mirroring on your existing databases in Azure. Once you turn on mirroring, your data in Cosmos DB databases or SQL databases is automatically replicated into Microsoft OneLake in Delta Parquet format. At the time of setup of mirroring, initial snapshot is taken, and then all inserts, updates, deletes that come in after that are automatically replicated. Now, once the data is in OneLake, all of the analytical engines in Fabric can directly access this data without further data movement. You can also run queries directly on OneLake, protecting your source databases from the performance impact of these analytical queries. Now, Cosmos DB does not use analytical store or change feed as source CDC for this solution. We are using an internal technology, and so continuous backup is a prerequisite. The replication is done in such a way that there is no impact to the performance or the request units of your transactional workloads. Let's take a quick look at how mirroring works. Here, I'm in Azure portal for Cosmos DB account for retail order processing. I can see all of the containers that have information on order status, items per order, product and customer details. Let's analyze this data in Fabric. To get started, let's navigate to Data Warehouse, and let's click on the Azure Cosmos DB database. Now, if you do not see these mirrored tiles, it may mean that you need to enable mirroring in your tenant admin settings. Let's give this mirrored database a name and click Create. Now we have to choose the source account and database to connect to. I can either create a new connection by giving a Cosmos DB endpoint URL, or I can pick one of the existing connections. I'm going to pick an existing connection to the account that we just looked at. Now I have to choose the database that I would like to mirror. Let's pick the Orders DB database and mirror this. At this point, all the data in the containers of Orders DB database is getting mirrored into Microsoft OneLake in Delta Parquet format. Now this is going to take a few seconds to a minute, so let me show you the source database view that we have built into Fabric. Here in your mirror database, you can look at all the containers in your Cosmos DB account. We have really built the Data Explorer experience as it is from Azure portal into Fabric. We've built this as a convenience, so you can browse your containers and execute queries against them without navigating away from Fabric. You can only read the data. You cannot write to your containers from here. And any operations done here will accrue RU charges in your Azure. Now let's monitor the replication status. We can see that the containers are still running. Each of the containers are represented as a table in Fabric. Once a replication is done, we should see the total rows replicated as updated and the last refresh time updated. Let's refresh this. It may take up to 60 seconds for this to reflect. So we can see that the data is already replicated. So we are now ready to analyze this data. Let's navigate to SQL Analytics endpoint in Mirror Database. Here, we can see all of the containers as tables. We can see the schema. And we can run select top 100 queries. Let's write a new query to do a cross-container query. So this is joining the data across different Cosmos DB containers, running complex aggregation functions like sum. Running this directly against your Cosmos DB database would be impactful to the performance and cost. But now with Fabric mirroring, this query runs directly against OneLake. And as you can see, it's very fast. Fabric has invested in many performance improvements to process the data in Delta format very efficiently. Now we can also, with mirroring, not only do we create the initial snapshot, but we continuously, incrementally replicate all of the Cosmos DB data into Fabric. To show you an example, here we have a special offers container, and we're going to look at the records in this. So we have about 7,500 records in special offers container. I have an app here that's going to insert 500 records. So let's run this app. So now once the app is done, we should see 8,000 records. So I'm navigating to Azure portal, and let's do a count here. So we can see that we have 8,000 records inserted. Let's navigate back to Fabric. It is going to take us 30 seconds to a minute for this to reflect in Fabric. The data gets replicated in near real time into Microsoft OneLake. So now you can see that in less than 30 seconds, all of these records that we just inserted are replicated into Fabric seamlessly. Now, once your data is in Fabric, You can also join this data with any other data in Fabric. Some of our data is in SQL database, and we've already mirrored this data into Fabric. So now we're going to join the retail information in Cosmos DB with that of the store sales information in SQL. To do this, I'm going to navigate to warehouses and pick the SQL mirror DB. And so this is seamlessly pulling the data for SQL alongside Cosmos DB. In both cases, this is the data replicated into one lake. Now we can write a simple query that directly joins the SQL data with Cosmos DB data on filters such as order status and ordered by. And we can see that this runs really fast as it is running against the data in one lake. We can also select this query and visualize these results right away. With a single click, now we are able to build Power BI reports. The Power BI report here is picking the data from one lake in direct lake mode, and it is going to pick up any changes that are going to land into SQL DB or Cosmos DB seamlessly. You can also analyze this data that's in your mirrored Cosmos DB and SQL DB in Lakehouse as shortcuts and use Spark Engine from notebooks. You can really join the data across lakehouses, warehouses, mirroring, and shortcuts, truly giving you unified data estate for your businesses. Now I want to talk about pricing for mirroring. We are really making it cost-effective to build your analytic solutions using Fabric. With Fabric mirroring, there is no charges for using the compute for replication. The compute used for replication is not allocated out of your Fabric capacity. Also, the storage used in one lake for your mirrored data is free for each terabyte of your allocated Fabric capacity, which means that if you have F2 capacity in Fabric, you get up to 2 terabytes free. If you have F16 capacity, you get up to 16 terabytes free for mirrored data. Some standard charges do apply, like if you use standard Fabric services, such as lakehouses, querying in Fabric, or using Power BI reports. Standard charges do apply for using these. Continuous backup feature also will accrue standard charges if you're specifically enabling it for mirroring. If this feature is already enabled for your Cosmos DB account, there are no extra charges for using mirroring. Now I want to end the session by talking about how Azure Synapse Link works with mirroring. Mirroring does everything that Azure Synapse Link does, but better. First, mirroring supports open source format, Delta, that can be used with many engines that understand the format, that is, services like Azure Databricks, Azure H3 Insight, etc. You can seamlessly join the data that's landing in Fabric with all other data in there. And Fabric has invested a lot of effort into making it very efficient to process queries against Delta format. So you will see massive improvements on analytics queries, both in SQL and Spark in Fabric. Next, if you're using Azure Synapse Link on your accounts, you can enable mirroring alongside Azure Synapse Link. Change feed can also be enabled along with mirroring. All these three features work independent of each other. If you're using Azure Synapse Link for your production workloads, please continue to do so. We will continue to support them. Mirroring will support production workloads at GA. Thank you so much for your time, and we hope that you try mirroring feature.
Hello, everyone. My name is Tarunjit Singh. I'm a software engineering manager in MasterCard. Today, we will be going over on how MasterCard's Ethica Consumer Clarity product helps in reducing friendly fraud using Azure Cosmos DB. Before we dive into the presentation, feel free to reach out to me or Ginte, who is a software engineering lead at MasterCard, for any questions related to this presentation. So let's get started. You might be wondering what exactly is friendly fraud. So friendly fraud is when a cardholder identifies a purchase on their transaction statement as fraudulent and disputes it, sparking the chargeback process. In actuality, though, they or someone else in their household may have made that purchase. This could possibly happen because default transaction details sometimes contains incomplete or incomprehensible merchant information, resulting in the cardholder misidentifying the transaction as fraudulent. So friendly fraud accounts for as much as 70% of all credit card frauds, costing the industry over $132 billion a year. So how do we solve this problem? You might have seen your credit card statements and hoped if you could have some more information on certain purchases instead of the incomprehensible alphanumeric characters. So MasterCard's Ethica Consumer Clarity provides exactly that information. It gathers data from various sources, responds with a recognizable merchant name, location, logos, even purchase receipts to better identify the transaction you made in the past, reducing the number of chargebacks and saving the time and money for both the clients and the issuer of the card. It also now provides options to manage the recurring subscription that you see in the credit card statements. So you can now pause, cancel, upgrade, downgrade your subscriptions without leaving your credit card app. So how does Azure Cosmos DB helps us? Well, the most important feature of the consumer clarity is the low latency data access. We wouldn't want the cardholders to be waiting for the information to load in the app. The challenge for consumer clarity is to query a request over a huge volume of data and return the results within milliseconds. To achieve this goal, we use the point read feature of Azure Cosmos DB, which provides SLA of under 10 milliseconds. The volume of data at Ethica Consumer Clarity has increased over time and now has scaled to multiple terabytes, translating into billions of documents. We have recently doubled the data load, and Azure Cosmos DB was able to scale accordingly with no issues. Ethica Consumer Clarity has various sources of unstructured data and hence relies on Azure Cosmos DB's NoSQL data support. With many external entities making API calls to our system, there's a need to accommodate the traffic of millions of requests coming in every day. And Azure Cosmos DB has made it possible for us to handle the large number of requests within the specified SLA. There are other features from Azure Cosmos DB that we use, like data replication and failover switching policies. All we needed to do was to configure the policies to make sure the systems are aligned and fault tolerant. Azure Cosmos DB provides guaranteed write availability of 4 nines and read availability of 5 nines. And another great feature that we use is the autoscaling. Using autoscaling, Azure Cosmos DB was able to automatically increase or decrease the RU utilization based on the request traffic while reading and based on the data volume while writing. The out-of-the-box monitoring tools helps us in overseeing the performance statistics and maintaining the system. And we have experienced that the integration of Azure Cosmos DB with native services was very simple using the provided developer tools. At a very high level, the Ethica Consumer Clarity is a store and retrieve system where the ETL service extracts, transforms, and loads the files which are cleansed by machine learning models into the Azure Cosmos DB. And the API service serves the request from external entities by retrieving relevant information from Cosmos DB and responding back the results. The data loading process is fairly complex in Ethica Consumer Clarity, but I would like to highlight one of the use cases here. Azure Cosmos DB is able to load high volume of data from multiple ETL worker processes. At peak time, the ETL worker load billions of documents within the 12 to 14-hour time window. Azure Cosmos DB is able to support asynchronous ingestion requests from each of the worker and adjust to the variable number of ETL workers as they scale up and down based on the data volume. Also, the autoscaling feature in the Azure Cosmos DB allocates the number of RUs based on the ingestion volume. This removes any need to manually change in configuration if the data volume is too small or too large. Once the data is loaded in the Azure Cosmos DB, the replication configuration helps in automatic replication of data over multiple geographies and regions. If an instance of Azure Cosmos DB is down, there is an automatic service managed failover switching which allows the service from one region to point to an instance of another region. Although the guaranteed availability of Azure Cosmos DB is 99.99%, the application is more tolerant with the failover switch functionality. This concludes the high-level overview of how Azure Cosmos DB helps Ethica Consumer Clarity. in achieving its goals. I would like to now pass it over to Ginte for some technical details.
Thank you, Taranjit, for sharing the high-level context. Indeed, the Cosmos DB played a critical role making our API to be super fast. I am Guntek Kim, a lead developer in MasterCard, and I'd like to elaborate our success story, deeply diving into the technical perspective and how we integrated Cosmos DB into our system. Three main objectives we had when we started building our API were, first, application needs to be highly available following the MasterCard API standard. And secondly, to support high throughput, but at the same time to guarantee the extremely low latency for the end users and then their experiences on their mobile devices. Consumer cloud ecosystem is fully cloud native in Azure, and then leveraging the power of the cloud computing and its scalability. With the microservice design, the lightweight Spring Boot application is able to horizontally and then seamlessly scale within the Azure infrastructure. Furthermore, our RESTful API is fully reactive and then based on the project reactor, which supports non-blocking mechanism and then asynchronous processing of the request. And it did make stateless microservices scale better in a more predictable way. With all of these cutting-edge technologies, not to mention the convenient Cosmos SK for the Java, we are able to achieve our aggressive requirement of building high-functioning API, and which currently shows that on average 20 milliseconds of the end-to-end latency. While the guaranteed backend latency by Cosmos DB is less than 10 milliseconds and 95th percentile, it is a great accomplishment considering it is an end-to-end latency. It may depend on the data and then volume and how to design the Cosmos DB, such as physical partition, logical partition, etc. I'd like to say that Cosmos DB does its job really well and is lightning fast even if the data volume is huge in the database. Let's further look into how API design evolved, arriving at current status. As I mentioned earlier, one of the requirements was to support very high throughput, and our inbound traffic has been increasing tremendously at times. Sometimes hundreds of thousands of the documents are being read from the Cosmos DB in a single second. The key aspect of the design is to leverage the point width capability of the Cosmos DB. Two approaches team deliberated on at the design phase was simplicity with the querying document together versus low latency with the point width. And eventually, we designed our partition key to be unique for the point width to avoid any single queries from being made from the to the Cosmos DB. In order for us to do that, data was replicated with variation, so always the point width can be made is a big one tip at the beginning. Now you may be curious about how we dealt with the fast-growing throughput in our client application. In fact, we figured that when number of documents fetched at a time are not too significant, 25 requests, for example, it is the best to parallelize the point width with the traditional multi-threading model. Then what it could do when the item retrieved together become high. In our case, it is 200 payloads in a single request. Actually, there is a still way to accomplish this, which is backed by a case study and then benchmark from the Microsoft, which is balancing the number of documents and using the read many functionality of the SK. The result may vary depending on the situation, but in our case, we were able to establish the balanced approach of concurrently querying the data in a smaller group, which lowered the both latency and then RE consumption at last. So one lasting core piece that allowed us to be where we are is the Cosmos auto-scaling throughput. Particularly when your API has a fluctuating traffic, Cosmos DB automatically adjusts its scale almost instantaneously as the request volume goes up and down. Not only you get the cost benefit by having auto-scaled throughput, but it adds essential scalability to your solution, which definitely help with the latency and then throughput management. In addition to the API, it might be beneficial sharing our experiences on the data load side, which fundamentally contribute to our overall system architecture. As aforementioned, unique partition key and then point reading the data are the essential components of our low latency API, and it is possible because of this heavy lifting is done on the ETL side. Because of the periodic altering data set, which is large in volume at times, we needed to load the massive amount of data into a new container as quickly as possible. But it was challenging for various reasons. Even though we designed our application highly scalable, as you can see in the screen, accumulating small latencies from the Cosmos auto-scaling made a high impact on the total ingestion time. And furthermore, partitions started to split after reaching out the max storage size, which significantly decreased the write performance. So in such scenarios, the hack was to create the container with the largely provisioned RU, so that predefined number of the physical partitions can be created. This way, we could avoid partitions from being splitted during the entire data ingestion. Another advantage of preserving the partition is that data can be evenly distributed into the old physical partitions, mitigating the hot partitioning as low as possible. With this highly balanced and then concurrent data ingestion architecture, tens of terabytes data could be sent to the Cosmos DB at a very high scale as expected. Before passing this over to Tarunjit back, I'd like to share good customer experiences with Azure team and then Cosmos DB team. Not only it is a cloud database providing high availability, low latency, but MS support team has been really great and then highly responsible in terms of the troubleshooting the production issues. The abundant metrics information both available in Azure portal and then through the SDK as Cosmos Diagnostics also allowed us to build most complex monitoring alerting system, which is another thing to call out before wrapping up my presentation. Thanks for listening, and then over to you, Tarunjit.
Thanks, Ginte, and thanks to all the viewers for their time. I would like to welcome you to visit at MasterCard's Ethica Consumer Clarity page to learn more about the product, or you can reach out to us directly. Thank you all. Have a nice day.
My name is Robert Finlayson. I'm a Senior Product Manager at KPMG Australia. We utilize Azure Cosmos DB NoSQL database to store our conversational histories for KimChat. For the implementation of our retrieval augmented generation model within KimChat, we leverage Azure Cosmos DB for MongoDB vCore for storing our document embeddings. The utilization of both Azure Cosmos DB ensures that our architecture supports our highly efficient data storage and AI retrieval processes. For us, it's the new HNSW vector index. It's a graph-based data structure, and it's dramatically improved our search results and the performance across our document data set.
Thank you, Robert, Anita, and our friends from MasterCard, Tarunjit and Ginte, for those awesome presentations. Let's keep the show moving, but first let's take a look at our Twitter feed to see if we have any new tweets to share. So, awesome, it looks like we have two. We have one from Kevin, who's loving Azure Cosmos DB Conf so far. Venue could be nicer, that's what happens with remote conferences. And then we have another one from someone who's actually very SQL heavy, but really appreciates the Cosmos DB. Yeah, that's awesome to hear. All right, cool. So let's keep it moving with another presentation from Azure Cosmos DB Product Manager. You might know her from previous conferences, Deborah Chen. We'll also hear from William Harding of Avanade on using Azure Cosmos DB to make games.
Hi everyone, my name is Deborah Chen, and I'm a product manager on Azure Cosmos DB. I'm excited today to deliver today's session on how you can achieve good cost and performance with elasticity. Elasticity is a core differentiator of Cosmos DB, and what it means is the ability for you to automatically scale up and scale down based on your workload traffic. Cosmos DB does this automatically on your behalf while maintaining industry-leading SLAs on throughput, latency, and availability. Today's session will cover 3 very concrete, actionable tips you can use to improve your cost and performance today. We'll talk about how you can leverage autoscale in a new feature called dynamic scaling, which optimizes the scaling of autoscale for workloads that have different traffic patterns across regions or partitions and can help you lower your costs. We'll talk about best practices and guidance for choosing the right partition key and show a demo where you can see how much of an impact it has on both your cost and performance. And finally, we'll talk about how you can optimize your data distribution with partition merge. For today's session, let's look at this in the context of a real-world customer scenario. So today, we are all part of Contoso Retail, and we have two workloads that we're going to look at and optimize. The first one is a shopping cart workload for an online retail store, and the second one is an IoT telemetry workload that captures device telemetry from Contoso's warehouses. Let's start off in the Azure portal, where I have my shopping cart container. You can see the shopping cart is partitioned by cart ID, which is a good partition key in this case because it has high cardinality or high number of distinct values. And when you typically query for a shopping cart to show on the display page for a user, you typically query by cart ID. You can see this is the schema that I have. And currently, I have provisioned 10,000 RUs autoscale on this. Autoscale is a good choice in this case because we know retail workloads tend to be variable, and it's hard to predict exactly the throughput you need. So having a good 10x scale range that autoscale provides is really helpful. Now let's take a look at how our workload is actually running in production. I also have this workload set up in two different regions, East US2 and West US2. And today, the workload is operating in the US, but in the future, I can expand to any other regions in Azure. And if I choose to add a new region, Cosmos DB will do this automatically. So which means that as my workload is running, my data will be available in that region, and I can take advantage of that to provide a better user experience to the app and to the users in that region. So let's take a look at how our workload is actually running in production. First, I'm going to go to my Azure Monitor Metrics section and filter to my shopping cart container. Then I'm going to look at my total requests. So what kind of traffic pattern do I have across my region? Okay. Here, the blue line represents West US2, and the pink line here represents East US2. I can see that over time, my workload is actually different across all of the regions. Sometimes East US has more traffic, sometimes West US has more traffic. So what does autoscale do? If I look at what autoscale is doing today, I use the provision throughput metric to see how much autoscale is scaling at any moment in time. However, it looks like regardless of the traffic pattern, in each region, autoscale is scaling to the same RUs at every point in time. So why is this happening? Let's take a look at how autoscale does this today and how we can leverage a new preview feature to get better scaling at a per region level. Today, autoscale scales each region and partition you have based on the most active one. So this works really well when your workload is very uniformly distributed across all the regions and partitions, but not so well when your workload isn't, which is the kind of workload we have here for the Contoso Retail. In order to fix this, you can leverage a new preview feature called dynamic scaling, in which autoscale will now scale each region's throughput in the partitions independently. This makes it a great fit for non-uniform workloads. So let's see the impact of this in action. First, I'm going to make sure that I have the feature on. So the feature will scale each region and each partition independently. So you go to your features blade and make sure the feature is on here. Now, I have an account where I've already enabled this feature, and I've actually run this workload quite a bit for a while. And I can see, once again, I have a different traffic pattern between East US and West US. Okay. Now, however, because I have this autoscale dynamic scaling feature on, if I look at my provision throughput, which again is what autoscale is scaling to at any point in time, I see that each region is scaling differently. At the times that East US2 is less active, East US2 is only scaling to what East US2 needs and West US2. That means previously, rather than scaling everything based on whatever is most active, we now scale each region based on its actual usage pattern. This means that everything here, this delta, is what you were previously scaling to and paying for before, which is now all cost savings for you. Okay. So if you have an autoscale workload, please check out the dynamic scaling feature to help you save cost on your non-uniform workloads. In this section, we'll talk about some best practices and strategies for choosing the right partition key for your workload. A good partition key in Cosmos DB will make sure that your queries are efficient and that you have good performance. If you have a good partition key, it ensures that there's no bottlenecks on hot partitions, and it also makes sure that you can really take advantage of the throughput that you've provisioned. Let's dive into Contoso's IoT workload and see in practice via a demo just how important the partition key is and how it makes a big difference on both cost and performance. Switching over back to my portal, here I have a database called partitioning demo with 2 containers in it. Both of them store the same exact data, some device telemetry data here, but there's one key difference. This container here is partitioned by date, while this container here is partitioned by device ID. In general, when picking a good partition key, you want something with high cardinality or something that has many distinct values. When you compare device ID and date, even though it would seem like both of them have high number of distinct values, the reality is we also need to make sure that at the per second level, at any point in time, it has high cardinality as well. As a recap, Cosmos DB, when you insert data into the database, looks at the partition key value of the document you're inserting and picks the right underlying physical partition to store your data on. This means that if you have a partition key with many distinct values, Cosmos DB will actually hash those partition key values and distribute them evenly across all the underlying physical partitions. So in this example here, I provisioned my container with 50,000 RUs each, which is a lot of RUs, but I really want to exaggerate to show you just the impact of how the partition key makes a difference. So I'm going to switch to my VM here and run a data generator. And all it's going to do is insert some data that looks like this into the Cosmos DB container. In this first demo, I'm going to ingest data into my container that is partitioned by timestamp or date. Now this means that today's date is the same for every single document. And you can see that as I start writing data, I'm really getting bottlenecked on the amount of throughput I can achieve. This is because all of the data is being written to the same physical partition because they all have the same partition key value, which is today's date. Now this means that even though I provision 50,000 RUs, I'm only able to actually use and leverage 10,000 of them, which is actually a lot of wastage there. So how can we improve that? If we instead partition by something with higher cardinality, both across time and within at a per second level, like device ID, say I have thousands of devices that we are collecting telemetry for, you can now see that I'm getting much closer to the 50,000 RUs that I actually provision. In general, when you're choosing a partition key for Cosmos DB, definitely encourage to put some thought into it. Choose a key that optimizes for your workload pattern, and try to make sure that the key ensures an even distribution of storage and request volume. If you have a write-heavy workload like the one we just looked at for Contoso, you want to really choose a partition key that has high cardinality, both overall and per second. Things like device ID, vehicle ID, things that have lots of distinct values. If you have a read-heavy workload, you typically want to choose a key that you can use on most of your queries, while still ensuring that that key has high cardinality as well. Now let's move on to the third and final strategy I'd like to share with you today, which is on how you can optimize your data distribution with another feature called partition merge. So what are the scenarios where this feature is relevant? If you as a customer have ever deleted a large volume of data from your containers, maybe you realize I don't need to store 3 years of data anymore, I just need 6 years of data in my container, or if you've ever just accidentally scaled up really high, and then now you want to lower your RUs because you realized you actually didn't need that many. So let's take a look how partition merge can help with both of these scenarios. As a recap, Cosmos DB distributes our data across all the physical partitions in order to guarantee scalability. For example, here I have a container with 50,000 RUs, and the data is currently stored among 5 physical partitions. This container is pretty well utilized. Each partition is pretty full. It has around 45 GB of storage in it, and everything is great. However, let's say now as a customer or Contoso, we want to delete some historical data, either by deletion or by using TTL to expire that data based on the timestamp. If we do that, then we can see the partition layout stays the same, but now there's much less storage on each partition. At the same time, because I don't have as much data, I'd also like to lower my throughput. If I do that, if I lower my throughput from 50,000 to 10,000 here, I see that now I have some RUs fragmentation. I don't have as many RUs as anymore on each partition, and I also don't have that much storage. So what can I do to fix this? Okay. The answer is to merge your partitions, to use the partition merge feature. Partition merge allows you to reduce the number of physical partitions in place, and Cosmos DB will automatically determine the right layout based on your current storage layout and RUs. So there's no calculations you really need to do here. All you need to do is point the API onto your container. So in this example, after we kind of defragment this collection, we can see we can actually fit our storage on a smaller number of physical partitions and have better throughput allowed on each one. This also has the benefit where if I'm running queries that typically need to talk to multiple physical partitions, if I have fewer of them, those queries can now run more efficiently as well. Okay. So let's switch over to the portal again to show you some metrics and a demo of how you can leverage this feature. So I've previously created a container called merge container. And as you can see here, just like an example, it has 5 physical partitions and not that much data on it. So I just use this metric called physical partition size, split it by physical partition ID, and I can see that I don't have that much storage on it. At the same time, I can use another metric called physical partition throughput that tells me how many request units, how much throughput is on each physical partition. In my case, I actually had set this to set this overall container to 50,000 RUs before. Now I lowered it to 10,000 RUs. So with 5 partitions, I have 2,000 RUs on each. Okay, let's see how we can actually defragment or merge this container. Okay. So we have both PowerShell and CLI capabilities available for this. But basically, all you need to do is run this what if command here. If you just want to see the preview of the results, and then if you remove what if, it'll actually run it. So here, I've actually run this command previously, where all I pass in is the name of the container, the resource group, and the account name that it's in, and say, based on the current settings of the container, what will happen if I do a merge? And the result here is that actually with this small amount of data, this can all fit into one partition with around 4 GB of storage. So just as a recap on best practices, this is typically something you want to do when your container has reached your steady state. So if you know you're going to be adding a lot of data in the future, or you know you're going to be scaling up a lot in the future, no need to worry about this. This is more for these scenarios where you've either scaled up really high and realize you need to scale down, or you've deleted a lot of historical data. As a best practice, set your RUs to the steady state that you want before you run the merge. Cosmos DB uses that as an input into the partition layout. So the more accurate information you give us, the better it will do. And also, in order to take advantage of this feature, you'll need to use the latest merge-aware SDKs. So on our documentation page, you can find the latest versions, which are compatible with partition merge. Let's just make sure that if you can run merge while your operation is running, and there's absolutely no impact to your production workloads. So in summary, we've covered 3 different tips you can use today to improve your cost and performance on Cosmos DB. Thank you so much for tuning in, and looking forward to see what you build with Azure Cosmos DB.
Hi, I'm William Harding. Thank you very much for having me. I'm going to be presenting on procedural simulation, AI creativity, and stochastic modeling, and I'm going to talk about how to use Cosmos DB, OpenAI, and other tools to build interesting and rich digital experiences, and some frameworks on how to do that. My name is William Harding, and I work for Avanade. Avanade is owned by Accenture and Microsoft. We're one of the world's best providers of Azure implementations worldwide. I work within Data and AI, which is a global resource pool, and I help clients all over the world build projects similar to some of the infrastructure that I'm going to show you here. This is in the process of a game, but you're going to see a lot of industrial application for it as well in the workplace. This is going to be in 2 parts. So on one side, I'm going to be talking about AI and how AI can be used to make content, and how AI can be used asynchronously in web experiences. And that's important for a lot of different kinds of use cases. But then I'm also going to be talking about Cosmos DB, of course, and I'm going to be talking about how Cosmos DB used in web applications can create real-time simulated experiences using the Graph API, and you can get a lot of really good, sharp web experiences by doing that. And I'm going to show you some of the infrastructure and kind of the best practices as far as how to do that when you build really complicated scenarios and web experiences for your clients. So I'm doing it in the context of this project, which is a game. This is a procedurally generated, AI-generated tool that takes a small amount of input and it creates a universe. The universe has planets. The planets have people. All of that data is stored in a Cosmos DB graph, the Gremlin graph. I'm going to go into some details about that. And I'm going to pivot over here to some of the actual experience. You can see this is using just open source web tools. I'm using Babylon.js for the web experience. Each individual planet has its own parameters that are associated with it. Each one has its own series of moons that orbit it. They all have their own parameters. This is all created stochastically, and I'm going to go into that in detail in a second. Each individual planet has a procedurally generated name and different attributes about it. The planets that you will have any amount of people on it, you can actually go to that. And also, this is AI-generated landscapes. Build these tools on the fly. And each individual population has its own attributes and components to it. And you can see these are all AJAX requests that are going to Cosmos DB to get and fetch attributes from the populations on this planet. And as you can see, as I'm interacting with it, Cosmos DB is able to fetch all of this data in real time. That's not all loaded in one experience. That would be too heavy on the system. Each one is a very small AJAX request. And because you can see in the top, I already have the root node of my graph here, I'm able to quickly traverse and get the data that's local to this information in the graph in the time that I need it. And I'm able to quickly go from different orientations by getting very fast, really clean Cosmos DB requests that have high read, high write ability. And the application works really well. It also scales really well. And in that note, while I'm talking about a game, because that's more fun to do in your free time, this also has industrial applications. You can see that things like the metaverse and digital twins will also use the same framework in order to build their environment. You're going to use, if you have that similar to that planetary hierarchy and population hierarchy, you're going to build an equipment hierarchy from your IoT data. You put some of your telemetry from ADX, you put that into a model, and you can make a simulation in your own workshop from the same tools. This is a very normal process and how we would do it at our work. So take a second, like, what is stochastic modeling exactly? You may already know this because it's very academic stuff, but it's just it has an amount of randomness that goes into the model, which means each time you run it, it will be different. You can see here I have an example where a flip of the coin determines whether it's going to be heads or tails, and if you run it over a large number of times, you should get about 50% at the end of that model. This is obviously not the best use case, but if you had an industrial application, for example, is this machine likely to fail, or how many people will visit this restaurant in a day, and will it ever peak to a certain amount, or what kind of problems will you have? You can look for bottlenecks with stochastic modeling. There are all kinds of industrial applications that are used for it, for both industrial, finance, all kinds of things can use stochastic modeling. And as we're going to get into, Cosmos DB is a great tool to run and store that data so that you can build models really fast, which is an important component of building your model. And the same thing, if I take that same logic where I'm using a flip of the coin or some randomness, and I make a much more complicated system out of it, then you're starting to have what is a game. And ultimately, most games that are developed today are procedurally generated models or stochastic models that operate on these large data systems, and you can interact with them like this. Because I'm using Azure, I can have my application be a game that you can play online on a website, and it can interact with Cosmos DB as its data layer, and you can interact with this graph in the real world and thus have an interactive simulated experience that users can interact with. So that's a Cosmos DB component, and we talked about that part, how to make a website, how to make Cosmos DB a part of that. We're going to talk about AI and how that integrates as well. We're going to talk about some patterns for that. You can see, for example, this is the JSON that you get back from your Cosmos DB experience. This is a population that lives on this planet. We were just looking at them. And obviously, it's not very fun for an end user to look at it in this way. And building procedural logic, which is normally what you do in these games, is you have to write some if-then statements that's going to build a full sentence out of that. That's kind of the status quo thing that you would do. But with AI, you can make a much more rich experience very quickly by presenting that small amount of information and just asking AI to create a narrative for it. In this case, you can see these people who have the attributes. It's able to both create an image for these people, which gives you the idea that what they might look like and things like that, but also some description of how they interact. So you, instead of reading a JSON readout, you can read something more descriptive about those people. Makes your game a little bit more fun and real seeming for your end user. In the same way, you can use that to the classic pitch of the industrial metaverse is you could look at a 3D model of something and say, when was the last time this part was serviced? And that kind of components could traverse a graph, get that information, render it in this kind of way to a user experience. This goes back in the game, especially the amount it would cost to build all of these assets, especially if you want to have thousands of individual randomly generated experiences. You obviously couldn't, even if you wanted to, you couldn't pay a team to develop resources that fast to support your game. And AI can do it much more streamlined. So this infrastructure that I have in the repository is going to be very similar to what we would do in a production environment, with the exceptions that I'm using the development environment of a local host to run the experience. But you can see here, and I'm going to go into these in detail so you can get a closer look. But you can see a kind of a holistic model of how this infrastructure will be run. You've got on one side, you've got a series of microservices, the Azure function and the Event Hub, that are really just getting and setting little bits of JSON to the Cosmos DB graph. And that, as it's doing it, is going to be continuously placing and setting and getting data that goes into the graph. Additionally, the user has a layer which they can interact with the graph, and they can make decisions that would affect the simulation, and by that also affect logic that would go into it. This would be tedious to do in real time, especially if AI is in there, because there's a few seconds delay in having AI generate content. But I'm going to show you some ways in which you can moderate that to make it more of a streamlined experience for your game. So I've built custom connectors that connect the Azure Cosmos DB Gremlin Graph API that load that data into a set, and therefore can quickly, within my API, some convenience features that allow my application to quickly take an object ID, fetch it, and fetch all of the elements that are children of that, so I can quickly render a scene fast. That helps the web experience. And abstract that so then I can call it really fast. And that's in the library that's attached. I've also built a similar wrapper for very common RAG kind of tools of just being able to take a bit of JSON and say, hey, can you explain this to the end user? Or can you build a picture or something out of what's in this set? Build some general rules. You can test all of this in a development environment. In my process, I build all of this out in Jupyter Notebook so I can test the data science of it, and then I can take the logic of that and put it into the production application, because they're all inheriting from the same components. In that, the best way to manage this experience, especially if you have a user involved, a user cannot wait a long time for these processes to complete. And shouldn't have to, especially with Cosmos DB. You should be able to quickly get and set information in the graph. You're in this pre-game where the user is interacting with the website. They're just making a call to the website. They get some data back. The JavaScript is going to render it in a cosmetic way. The same experience where if there's something that has to take a couple of seconds or takes time, you don't burden the user to do that. You just pass it to an event route, and then an asynchronous function will build that and then put it back in the graph. So as you can see, what you're going to be doing is that Event Hub is going to trigger an Azure function. That Azure function is then going to interact with OpenAI or do some more complicated logic about some event that's happening in the universe. And then when it's done with that, it will spend its response DNA and then place it there and not burden the user about that at all. Then when the user goes back to their web experience, they're going to see that that has been updated and that it's now the scene has changed, which means populations have reproduced, or they've starved to death, or they have used some resources, or they've built new buildings, or things like that. That's all happening for the user's experience in relatively real time. And then OpenAI can finally place individual components that are going to be landed in a blob store that can be loaded as data assets in your game. Those are loaded by reference to the web experience. So Cosmos DB can get an ID, and it knows with that ID where to look it up in the blob store, so it can statically go and fetch assets if they exist and then render them in real time. That creates a very slick and very clean user experience to an audience. And the same if you were using this for a digital twin or some kind of digital twin-like application. You could see how if you had this event-based infrastructure, you could have that running all the time. Now, the stochastic modeling part. If we want to have a genuine model where something is always churning in the background, for example, machine parts or whatever is in your simulation, you're going to have one timer function that is going to be running, but it won't have any of the business logic. This is an important component. It won't do any of the actual business logic itself, but it will instead query the graph, get some information out of it, and then just send out a bunch of messages to event hubs that will then trigger other asynchronous functions that will enact that logic. Because there's going to be a limit on how long a timer trigger can run. If you'll get into the scale problems if you have all that business logic there. So all you do is it just gets some data from the graph, and then for everything that's unresolved, you just put out an event hub notice. The Event Hub trigger then takes all of those notices and it asynchronously can place all of them in the graph. Azure Cosmos DB is generally known as high read, high write, so it can handle that load, and there's no user waiting for the consistency. The eventual consistency of the Azure Cosmos DB is going to ensure that the model is kind of an always-on churning thing. These can be references to specific IDs, for example, device IDs, digital twin IDs. They could be, in my case, every object has a unique object GUID, and that way I know when I can select an item, if it has an action that's associated with it, I can send off a notice to resolve that action, and a different function will pick that up and resolve that action. That makes it very easy to have an ongoing churning model that's going to present all of the data that you need in your simulation. So that whole system working together, again, very, very small number of components. This is very easy to build, easy to run. Your website is the interactive layer, but you're really just kind of getting and setting items from the Cosmos DB graph. Anything else that takes more than a web speed amount of time is really going to be handled by asynchronous functions that are going to run all of those jobs in the background. And the user is oblivious to the time difference of those when they happen. That means that each of the individual components creates experience. There is a genuine model that's happening in the back. You're using general common random features to create random events or random things that could happen. Or if you're planning to design a system that's designed for chaos, you're building components that break or fail. And then you can have that in a simulation. You can bring that out. Of course, Cosmos DB can handle a lot. So you can not only build one simulation of the same model, but you can replicate it to build any number of asynchronous models running at the same time. That's it. Thank you very much. Feel free to reach out to us if you are considering running a model like this. It's a personal project of mine to build these kinds of systems. And I am eager to connect with people who are building similar experiences, either for hobby projects or for industrial applications. Thank you very much.
Thanks, William and Deborah. Love the talk on Cosmos DB, elasticity, and gaming. What did you think about Deborah's talk?
Yeah, I thought her talk was super filled with like really good information. Just some highlights that I saw, like auto scale per region per partition is a super new feature that we released last November. Just wanted to touch on how powerful the per region auto scaling is.
Yeah.
I think she mentioned that now you're able to scale in different regions, and previously if you were very active in one region but your other regions weren't as active, you were getting scaled and billed for both of those regions at the same price. So it was like 2x of whatever you were paying right now for that extra region. But now with this new feature, you can add a new feature or add a new region for disaster recovery. Yeah. And the price for that new region might not be as high as it was before because it might be idle for most of the time and you're not using it as actively before. So if you were ever considering adding a new region to Cosmos DB and you use autoscale containers, highly recommend checking this feature out. Probably save you on costs and just gives you that extra layer of protection with the disaster recovery region. There are also a lot of other features she mentioned, like hierarchical partition keys and merge as well. Yeah. Merge is a really good feature if you've accidentally scaled up too high and now you realize you need to scale down lower, and you can bring down your offer after you do the merge as well. So definitely check those out.
Yeah, I mean, I think oftentimes we hear, at least on the product side, how do we reduce costs or help customers reduce costs, but still have really good performance? There's always that trade-off, right? Either you want really good performance, but then you have high costs, but or then you lower your costs, but then you have kind of not that great performance, right? With all of these like tips and tricks Deborah shared, I think this would give customers a lot of like ideas on what they can do to help reduce the cost, but still keep the performance really high. And then also we talked about choosing the right partition key, right? Yeah. Oftentimes we hear like, hey, what is my right partition key? Or like, how do I configure this so that it works great with my scenarios? And I think Deborah gave a lot of great tips on how to choose the right partition key for different types of workloads, like read heavy, write heavy workloads. Always mentioning to have high cardinality with the type of partition key that you choose. But yeah, this was really amazing, great talks. So folks, we are almost to the end of the show. And if you missed any sessions or you want to watch our exclusive on-demand sessions, all the talks will be available after the show on YouTube. I think the link is below. And we'd also love to get feedback from you on how we did. How was the show? Did you love it? Did you have a great time with us today? If you did, fill out the survey with the event code 21627 and let us know how we did on that.
Yeah, one thing to note with Deborah's talk, actually, we mentioned partitioning and how instrumental that decision is for your overall Cosmos DB experience. In the past, a lot of our customers have said that we messed up, we didn't realize this partition key wasn't actually a good choice, and now they wanted to find a way to change that partition key. We actually have a new feature in our portal that you can use to do this, and it's basically a really good interface where you can hit that change partition key button, put in the new property that you'd like to partition on, and then it'll automatically create a new container with a copy of all of your data from that prior container with that new partition key. So if you are, for example, using a synthetic key right now, and you could actually benefit from using a hierarchical partition key. So if you're a multi-tenant application and partitioned on tenant ID, you can actually use a synthetic ID to avoid those you could use a hierarchical partition key to avoid the cross-partition queries that synthetic queries give you.
Yeah, so it makes it like super easy for customers to like modify it after the fact, right?
Yeah. So definitely recommend checking that experience out. It's also a good way to just test different partition keys when you're first starting in Cosmos DB to actually solidify on the right one.
Yeah.
All right. So now we're on to our final session of the day. Can't believe we're already over.
Yes.
This is from Massey, who you heard in our keynote from TomTom. But first, let's hear how New Day is using Azure Cosmos DB.
I'm Alessio Franceschelli. I'm a senior principal engineer at New Day. Azure Cosmos DB plays a pivotal role in our architecture by serving as a backbone for our data storage across a multitude of domains. We use Azure Cosmos DB to store customer data, support our onboarding processes, stream data for real-time system. Essentially, like we leverage it for a multitude of domains. Azure Cosmos DB has supported key operations like our acquisition for Flow, improving our time to market for new features, and enabling us to offer faster, reliable APIs to our aggregator partners. And thanks to this scalability, we've been able, even when the design was not really optimized for cost, to handle the traffic and be able on our own time to optimize the service later.
Hey, fellow developers, greetings from Amsterdam, the home of TomTom. I'm Massi, and I'm a staff data scientist here. I'm going to tell you today about developing the intelligent vehicle assistant that TomTom made. This assistant is an AI app that's built using various Azure bricks, including Azure Cosmos DB. So I hope you'll learn something about building AI apps. To set the context about the app we built, I'm going to have to tell you a little bit about who we are. Essentially, everywhere where there is location data and mapping services, there is TomTom. For you as a developer, that means, we are a place to find APIs and SDKs for, location tech. So if you need something like geocoding a bunch of addresses or showing some maps on a website, have a look at the developer portal. So let's get down to business. What is this AI app that we've been working on? Well, connected cars, meaning connected to the internet, they need some kind of digital cockpit software for all those nice big screens. And there's usually a lot of location tech involved. So we offer a platform to let car makers build such cockpits. And within this context, we asked ourselves, what could it be to actually have a conversation with your car? And what can conversational AI mean in your car? Well, we already had some experience integrating various voice technologies into our cockpits. And so we already knew a thing or two about, the current state. What we knew was, first of all, that drivers are still having some trouble understanding, or interacting at least with complex in-car technologies. So if your assistant doesn't understand everything you say, you're going to have to navigate some very complex menus, for instance. Next, even basic tasks sometimes can fail, like finding some kind of open restaurant, or maybe changing a car setting or finding an EV station. So you might recognize the feeling of not being understood by your car. Well, if you have to give pretty explicit commands, it's not quite conversational. And lastly, in principle, voice interaction should be safer than touch interactions on a screen. But if it doesn't understand you, it can lead to frustration, and it actually gets worse. Now, it turns out that generative AI is a game-changing enabler to potentially solve this. So if you have access to a more conversational assistant in your car, it can probably help with this. So I'd like for you to see this for yourself, so let's cut to a demo.
Are there any places where I can charge my car during the game?
I found a few charging stations near Soldier Field. There's a charge point station at 1410 South Museum Campus Drive, Chicago, Illinois, with 4 out of 8 chargers available. Another charge point station is at 1201 South Prairie Avenue, Chicago, Illinois, with 1 out of 2 chargers available. The closest one is at 1410 South Museum Campus Drive.
In the meantime, I heard about 2 new restaurants in town, Daisy's and Warlord. What can you tell me about them?
Daisy's is a restaurant located at 2375 North Milwaukee Avenue, Chicago, Illinois, with a TripAdvisor rating of 4.5. Warlord is an American restaurant located at 3198 North Milwaukee Avenue, Chicago, Illinois, with a TripAdvisor rating of 5.0. Both are within a reasonable distance from Soldier Field.
Okay, so let's go to Warlord.
You're all set to head to Warlord at 3198 North Milwaukee Avenue. The trip will take about 20 minutes, with a minor traffic delay of 2 minutes. You'll arrive with 97% battery. Enjoy your meal.
I can't find the USB port to charge my phone. Can you help me?
The USB ports for charging and data exchange are located in the front compartment of the central tunnel. Lift the 2 half lids to access the ports. There are USB ports, Type A and Type C, available.
Okay, I hope that video helped you to believe that actually AI in this case is more than just hype. It's probably going to enable new kinds of experiences and new ways of building apps. I really hope you're wondering, how we got here and how we actually build AI apps. So let's get down to that. We're clearly going to need, as a starting point, some kind of large language model, some form of AI to build this with. So we started out with, being inspired by ChatGPT, we went for one of the GPT models. But a brain in a vat is only so useful, so we're going to need at least ears and a mouth to be able to talk to it. Hands-free, without typing. So also, we are going to need some way of interacting with the real world. For instance, if you want to roll down your windows or you want your assistant to interact with your navigation system, it's going to need to be able to do that, so to take action in the real world. The core concept here to look out for is something called functions or tools or plugins or actions. There's lots of variants of this idea. Basically, any way for your AI to enact change in the either digital or actual world. Then, a conversation wouldn't be quite a conversation if there was no memory involved, because talking to a goldfish is no fun. So we need, some place to store memory and to manage it, especially the memory related to the conversation. So we're going to need a database. And then lastly, as you might know from, for instance, using ChatGPT, the knowledge, there is some kind of knowledge cutoff. It's just based on the knowledge it has. And people often want to have the answers based on their own data. So for this, we're going to need some kind of knowledge base. We went for a dynamic approach using RAG, Retrieval Augmented Generation, over fine-tuning on some kind of fixed set. But let's bring in some Azure components, just off the shelf as a starting point, so that we're off to a good start, and we can put our efforts to testing the core concept, proving our concept. For the brain, we went with Azure OpenAI so that we could, get a grip on the privacy part. And I think other instruction-tuned models will probably also work. Play around. For the ears and the mouth, just rest assured that there is some kind of Azure component. There is a speech product. For the hands, well, this and wiring everything together to the brain is really where the rubber meets the road. So you will want to do the work and differentiate on building the hands and connecting them to the brain. Then the short-term memory, well, Azure Cosmos DB is pretty much the perfect place to store your conversation state. And I especially believe that adopting some kind of NoSQL database here helps because you can quickly iterate, in the prototyping stage, especially quickly iterate on the schema and the format that you want to store these in. Next, knowledge. So to manage knowledge, you're going to need some kind of search index. Even more interesting is if it's a semantic search index. So using a combination of Azure Cosmos DB and or Azure AI Search, these are really the ingredients to build such a knowledge base. We'll talk about that a little bit later. So these are quite some moving parts. We didn't really add them all at once because when it really comes down to doing a proof of concept, you want to prove specific concept. So I consider the core technical concept here, the setup of how the LLMs connect to the hands. So it's essential we validate this first. How? Well, we iterate, iterate, iterate. So starting from version 0, which is barely a version at all, we're just in a playground, which is where I bet that half the AI apps probably were born. So you take a prompt to test an idea, and you see if it works at least once. So in our case, this was some variation of this React prompt after reading some paper, and you see if you can make this work. Well, it worked at least once. So what's the next step? Well, the next iteration was trying to tie the brain to some actual TomTom hands. So given that this was early 2023 and LangChain 0.0. something had just came out, we went and just adopted this because it's a great starting point. So once you've done that, we now have the brains connected with the core skills, trying to test the core concepts of what having a conversation in your car could mean. But to take it one step further, this only works on my machine. So really, we want to get feedback from people around us. So it's much better if it's some kind of shareable app. So what we did is we created a cloud app, and we let it grow up a little bit. So how we did this was we started with some kind of bicep template. This was the first time using infrastructure as code for me, but it was quite doable. And this was also the way to add Cosmos DB for the memory management, because you need this. Otherwise, it all lives in memory and it will be forgotten. Nowadays, there is also a shortcut here from the first step to the third step, just straight up from the playground. You can deploy an app with memory using Azure Cosmos DB. Look out for that. Well, we didn't have that available. We wanted to go also one step further, and actually, to get to the value, you need to integrate into some kind of old or new product. So we did this, and on the way, we also had to harden a bunch of things. For instance, think of your quality assurance framework. How are you going to judge if your app is doing what it's supposed to be doing if it's based on AI? And, well, you can imagine that getting production ready involves a lot more of these kinds of things. Usually, some kind of framework will get you off the ground fast, but you have to be also willing to ditch it at some point. So we had to ditch LangChain at some point. So what we ended up with on a high level, some different integrations in the vehicle, and a large part in the cloud with all those yummy components that we talked about before. What I'd like you to take away from that is actually we put a lot of these components together as starting points, so off-the-shelf components, so that most of the energy can go to the core concepts. And for us, that was how we integrate with TomTom's location services. What types of choices did we have to make when developing an AI app? Well, I think some of the interesting choices to talk about with you, considering this is about Azure Cosmos DB, are about memory and knowledge. So when it comes to memory, as the conversation length grows, you're going to have to think about how to keep it small, or if you're willing to wait for more latency, because as conversations get longer, most AI apps will get slower. So you're going to have to make some kinds of trade-offs here. So tips here are, for instance, using some kind of time to live, or trimming. There are various techniques for this, and I think we're going to hear much more about this in the coming year. Next, knowledge. So this is where this pattern called RAG, Retrieval Augmented Generation, comes in. Tricky things here are, how do you decide which documents will appear in your context? How long should they be? How do you ingest them? These are all things also I think we're going to hear much more about this year. In any case, what you should know is that for both of these topics, there is Azure Cosmos DB. So look out for words like vector search, conversation state. There's a number of guides and templates available. And if you're using a framework like LangChain or Semantic Kernel or Prompt Flow, I bet there's already some ready-made classes for you to start the integration. Now, what I'd like you to take away, first of all, what I find personally exciting is that, when you're building AI apps, this is almost like a new programming paradigm. And so there's new patterns like this RAG, but also you're very often programming with natural language, something very different. Now think about how you're going to test such apps. Yeah, totally new paradigm. So the main tip I have here is, prototype and iterate. So test ideas early in the smallest way you can and build from there. What really can help with that, if you want it to grow up a little bit more, is to involve different cloud services so that you have some kind of shareable app you can just deploy. And finally, AI memory and knowledge management is hard, and I think this is going to be a big theme for this year. I hope you learned something about building AI apps. Hey.
Thank you, Alessio from New Day and Massey from TomTom for helping us close out that day. Wasn't that a super cool demo?
I love that demo.
I feel like I could definitely use that in the car.
Yeah.
Just if I was going somewhere and didn't know where something was, instead of like
searching. I mean, that's what we do now, right?
Yeah,
we search on some map system and then try to figure out what restaurants we want to go to, where can we charge our cars, or where can we get gas, and this actually does it for you.
Yeah, super cool. So just a reminder that you can find all of the sessions in a playlist from today at aka.ms/Azure Cosmos DB Conf. If you missed any sessions, or if you want to watch the sessions that we've pre-recorded, they're all in there as well. And Steph will take us through some more resources.
Yeah, I mean, today we learned so much about integrations with AI and Cosmos DB. And if you haven't already maybe dipped your toe into AI, you can continue your AI app journey and check out the resources at aks.ams/Azure Cosmos DB Hackathon for Microsoft developers learning hackathon.
We also have a special offer for current Azure AI and GitHub Copilot users. So this is the Azure AI Advantage offer, and you can save up to $6,000 on Azure Cosmos DB to accelerate your AI apps. The link above is aka.ms/Azure AI Advantage. Lastly, as we close out on today's conference, please fill out the survey with event code 21627. You can follow the link on the screen, or you can just scan that QR code from your laptop or your TV right now from wherever you're watching, and go ahead and fill that out and let us know how you did so we can implement that feedback for the years to come. Super huge thank you to all of our speakers, our organizers, and the crew here that helped us put on such a great show.
Yeah, thank you so much. I really had a great time. I don't know, Tara, I think hearing from all of the speakers, I really enjoyed my time here today. And thank you everyone for watching. I'll see you next year.
Yep, see you guys.
Welcome.
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 Welcome. Welcome.
Welcome.
Welcome.
Welcome to Azure Cosmos DB Conf 2024.
Welcome to Azure Cosmos DB Conf 2024.
We are so...
Thank you for joining us for Azure Cosmos DB Conf 2024. See you next year.
Thank you.
Thank you. Thank you.
Thank you.
Thank you.
We'll see you next year.
We'll see you next year.
We'll see you next year.
We hope to see you next year.